Welcome.
Okay, test, test, test. All right. Hello, everyone, and welcome to the Polkadot Mini Summit here at ETHDenver. My name is Bill Laboon. I am the Director of Education and Governance Initiatives at Web3 Foundation in Zug, Switzerland. I'm going to do a very brief overview of Polkadot. There's a lot to say and not a lot of time to say it in. So we'll go right into it. So when Polkadot was first thought of, mostly by Gavin Wood, who was CTO of the Ethereum Foundation, developer of Solidity language, he realized there were a lot of problems with blockchain technology and the blockchains that were out there at that time. So first, they can't communicate with each other. It's very difficult for one chain to communicate trustlessly with another one. Even trustfully, it's difficult. We see a lot of bridge hacks even today. They can't scale. We see lots of problems with scaling on all kinds of parameters in terms of transactions per second, size of the transactions, etc. Poor security. We see a lot of networks get attacked by hackers. They can't be easily customized. If you want to create another EVM chain, that's relatively straightforward. But if you want to do something special or specific, it's much more difficult to do. Poor governance, often governed by a multi-sig or maybe no governance at all. And upgrades are difficult, which means it's problematic to future-proof them, to ensure that as new features come along or as problems are seen, that you can't update them. So how do we solve all of this? Well, a big idea behind Polkadot and solving a lot of these problems is that having a single chain is actually a really bad idea. There isn't one size fits all. One use case may be really helped by having smart contracts on your chain, other use cases not, some with UTXOs, some with accounts. There's all kinds of different things that you can do when you're creating a chain, and all of these chains should be able to interoperate with each other. And it turns out, we'll talk about why, but having all of these chains solves a lot of other problems that we saw in legacy blockchains. So Polkadot is what we call a heterogeneous or heterogeneously sharded multi-chain protocol that connects and secures blockchains with pooled security and interoperability. And I'm sure you've heard a lot of buzzwords already at ETHDenver, so it's sort of a very easy translation. Polkadot is not just a blockchain. It is a set of blockchains that can work together, talk to each other, and share in the security of the network. And it makes this easy by allowing you to develop a chain and plug in to the existing central chain of Polkadot, what we call the relay chain, and allow the developers of that chain to focus on what they do best, the actual rules of that blockchain, what you want it to do. So a very brief overview of the architecture of Polkadot. I've already mentioned the relay chain, or layer 0, which is the central chain of Polkadot. It provides economic security and interoperability to the chains that connect to it. There are also parachains that connect to the relay chain and can do different things. So we have Asset Hub, we have Kilt for identity, we have Moonbeam for EVM smart contracts, we have A-Star for EVM and other kinds of smart contracts. We have Subsocial for social networking. We have Zeitgeist for prediction markets. There are 49 different parachains operating right now on Polkadot and more coming all of the time. So this isn't theoretical, right? I see a lot of people who have developed these parachains out in the audience right now. They have been running on Polkadot since 2021. And there is room for many more to join. In terms of these chains interacting with each other, we use a technology called XCM, cross-chain messaging. This is live, has an average of over 2,000 cross-chain messages per week, over 640,000 in total. If you're interested in building one of these parachains, we provide Substrate with a Polkadot SDK, which allows you to very easily build your own blockchain. This is actually why I got into Polkadot in the first place. I saw Gav's talk at 2018 at Web3 Summit about he pulled a laptop out of a brand new MacBook, and then an hour later had a new blockchain with specific rules. And I thought that was super cool. And if you've ever done any development in something like Ruby on Rails, where you can very easily get a website up and running, you don't worry about all of the details of networking, you just focus on the rules, Substrate is similar. There are a lot of different libraries, what we call palettes, and you can choose which ones you want or develop your own, have them tied together in different ways and interact with each other in different ways in a very easy to use mechanism. Out of the box, you can very quickly get your own blockchain up and running. However, Substrate is not just used for building on Polkadot. If you think of it as sort of a diagram here, we have Polkadot, we have many different Substrate-built chains, but there are a lot of other chains out there that are built on this technology that people don't even know they're using Polkadot-developed technology behind the scenes. So this is one of the great things, I think, about Polkadot. It is very open source. You can develop your chain, decide you want to be a part of Polkadot, but you're not stuck there if you don't want to be. And conversely, if you don't come onto Polkadot and decide later you want to, and you build on Substrate, it's relatively easy to do so. A very cool thing about Polkadot is that the rules for both the relay chain and the parachains are not stored on the nodes. They're actually stored on the blockchain itself, which means it's very easy to upgrade, because any node that is following the rules of your chain, it's automatically going to upgrade as the chain goes to the next, what we call runtime, the next rules, if you want to upgrade. So it's a WebAssembly bytecode. It's actually on chain. You can view, you can see the rules of the chain, and interpret it yourself. It allows for some really cool functionality. One of the things that just got released, actually I think about 2 days ago, is something called Chopsticks on Polkadot.js, which allows you to fork a version of any chain and play around it with yourself. It gives yourself 100,000 tokens and see, all right, what would happen if I issued this transaction? What would it do? It's a super great developer user experience. Polkadot always has a lot of developers interested in it because you really can do some very interesting things, which you can't really do with other blockchains. Where if you do want to change how it works at a fundamental level, you have to do a hard fork, which requires a lot of coordination. And again, this is not theoretical. This is not something that I'm telling you, wait until Q4, it's going to be awesome. Polkadot Relay Chain has upgraded 52 times since launching almost 4 years ago. And the parachains themselves have also upgraded numerous times. Different parachains can upgrade at different times when they release new functionality. Polkadot is incredibly decentralized. We have a very full-featured governance system that is without what we call first-class citizens. One dot is one vote, and everything can be voted on and changed in the system. If you don't like the inflation rate, if you are against a runtime upgrade that's proposed, the dot holders are the only ones who can allow that upgrade to go through, or conversely, to vote against it. And there are actually dozens of referenda going on at all times in the ecosystem. The Polkadot governance, it's full of very passionate people with almost like political parties that have formed. So it's a very, very interesting governance mechanism. And we are not standing still. Of course, just like I mentioned, you can upgrade the chain, and we are doing that all the time as we add new features, new functionality, figure things out, etc. So I'm not going to have time to go into the details of all of these different proposed upgrades, but hopefully just the names make it sound like there's going to be some interesting stuff coming. Very quickly, Agile Core Time allows you to adjust basically what is the necessity in terms of core time for your blockchain. If you have a blockchain that requires a lot of computational resources, you might need more. If you have one that needs less, then you'll need less. So you can actually save money. Core Jam allows you to run things other than just parachains on the relay chain directly. Hermit relay chain, we're going to put more and more, we're going to offload more superfluous capabilities from the relay chain to allow more parachains to work on it. Sassafras increases the security of the validators, and we are really working on decentralizing the humans that are involved. That sounds kind of disturbing, decentralizing a human, but what we mean is that there should be more people involved and more abilities to get involved. And we have lots of different new programs that, coming out that help to, and features built into the blockchain that help this decentralization. So Polkadot solves a lot of the problems that we saw in traditional blockchains. Any chain on Polkadot can easily interact with others, handles heavy traffic at scale. When the inscription craze occurred on Polkadot, it didn't even blink. Fees didn't even go up. And there were over 6 or 7 million transactions in a day just on the relay chain. Again, relay chain didn't blink, and there were 49 other chains that also could have this similar amount of transactions per second. So if all of this has sounded interesting to you, working on an extremely scalable system that allows a lot of freedom to developers, we have a lot of assistance available besides an on-chain treasury, and we've had hundreds of teams have gotten funding from the on-chain treasury. Web3 Foundation has a grants program for people building technical open source things. Decentralized futures for people building on Polkadot. Decentralized voices to give more voting power to people. 1,000 validators program for people looking to validate. Lots of different educational opportunities out there. So if you are interested in any of this stuff, I will be around ETHDenver for the rest of the time here until March 4th. If you see me, please feel free to come and ask me questions. All right. Thanks, everyone.
Okie dokes, just bear with me one sec. I am gonna present you guys to Ingo Rube from Kill Protocol. He's the founder of Kill Protocol. Just, let's change this here. I need to open it. Oh, perfect. We're good. Okay, folks. Now, here we have Ingo Rube.
Thank you. Good afternoon. My name is Ingo. I'm the founder of Kill Protocol, and I'm going to talk about an idea how we can actually bridge identity from ecosystem to ecosystem. So when we look at identity management, let's first look at the 1990s. There, everyone had a set of usernames and passwords, and one was logging him into Amazon, one to Google, one to Microsoft, and that was, well, people didn't like that very much because they always forgot their passwords, or even worse, they used the same password and username for everything. So another idea was born, which came out in the 2010s, and that was the identity provider. Identity providers use things like OAuth to actually make a layer between you and the services. So basically you have a Google login or a Facebook login, and then you can use this to log into Pinterest, Discord, Zoom, and so on. You probably all use that. Of course, that has its own problems because it's somehow centralizing things, and Google, of course, collects all the data and sometimes uses the data for making money with it, which is probably not so good, and you don't own your identity. It's owned by Google. So how does it work? As I said, it's using OAuth and OpenID. Basically, you go to the identity provider by clicking on this button, login with Google, and then you get an ID token inside your browser, and then you use this and send it to we call it relying party, which could be Pinterest or Discord. And as Pinterest and Discord trust Google, and this thing is signed by Google, they can trust that you are actually this Google user, and then you can run around this platform. Now, when we look into Web3, it becomes even worse, actually. So here in the Polkadot ecosystem, we have different apps on different chains, the parachains, as we already heard, and all these things have applications on top of it, and of course we have Polkadot addresses. But of course we're at ETHDenver here, and in Ethereum you also have addresses, and of course they're not the same, but they have their soulbound tokens, and they have lots of applications which are relying on the soulbound tokens. But this is not compatible. So Soulbound doesn't work on Polkadot, and the Polkadot address doesn't work on Soulbound. And then, of course, we still have the Web2, and we have the Google with their ID tokens, which their applications use. So it's getting worse and worse, actually. And then just a little for the soulbound tokens. So what we use in modern identity systems is DIDs and verifiable credentials. These are international standards from the W3C, the World Wide Web Consortium. That's the people who brought you HTTP. And soulbound tokens are not compatible with that. Also, the verifiable credentials, the standard, they store personal information in the wallet of the user, which is actually also GDPR compliant and good for protecting your personal data. In soulbound tokens, it's a little bit like on the public blockchain where personal data shouldn't be. And of course, soulbound tokens are coupled with an Ethereum account, which makes it all very much basically connected to your purse, which you also maybe not want. So how does identity management in the Polkadot ecosystem work today? As I said, many of the chains of those parachains we just learned about, they have their own identity system. They're building identity over and over again, and they're building it in a different ways. They're building it sometimes compatible with standards, sometimes not, which is also not pretty cool, because then the user here has many different identities in one ecosystem, which is even worse than it is in Ethereum. And it has some limitations. So we are actually back to the one identity, one application platform, which is the 1990s. And they're doing things twice and triple and so on. And that is actually not what we want. So we invented something we call the DIP, the Decentralized Identity Provider. How does that work? So first we take a decentralized network, which is a parachain, in our case KILT, which does identity. It's this one purpose thing, what Bill just was talking about. We do identity and nothing else on our blockchain. So you can set up an identity in the KILT blockchain, and then you can use this identity in different relying parties, which could be the other blockchains running in the Polkadot ecosystem, the other parachains. And why does that work? That works because we have a truth link, as we just learned from Bill, between the parachains through the relay chain and through XCM. So the parachains actually can rely on each other. And you don't have to rely on a single party. You rely on a public permissionless blockchain, which is much better than relying on Google. That means that all the parachains can actually use now what we provide in KILT as an identity, but we are not limiting it to KILT. Also, other parachains can have their own view on identity and also use this mechanism to deploy it with the DIP and then offer other parachains their identity services. So it's not exclusively for KILT. So high-level architecture. We already heard about pallets. So pallets are like modules in the Polkadot world in Substrate. So we have two of them. One is the identity provider, the provider pallet, and one is the consumer pallet. So any parachain that wants to use the DIP just imports the consumer pallet into their runtime, and anyone who wants to be an identity provider just imports the provider pallet. And then those two talk about a truth link together and export identities. How does it work? So the user at one point has to say, I commit my identity which I created on the identity provider, and then going to the relying party, in this case it would be Polymec, which is a parachain, they say dispatch as, and then that would mean that in this case, now with this identity, you can actually execute extrinsics like transactions on this parachain, which is totally powerful. And of course, you can do it as often as you want. And you don't necessarily have to do this with Polymec. The same thing would work, for example, with Energy Web. So what we got as advantages here, identities become portable. We have not the one identity, one application, but a one identity, many applications mechanisms. The chains can focus on what they do best. That is basically what they do for a living. And they don't have to care about identity, just import the identity functionality from the identity provider and use that. And by using DIDs and verifiable credentials, we can also decouple the identities from the crypto accounts. Oh, that's actually. Of course, it doesn't. So this identity provider thing does not only work between blockchains; it also works with RPCs. So applications can also talk directly to the KIL protocol. But they now have the additional feature that they can use the DIP to communicate also to other chains. So it's a chain to application or a chain to chain communication, which is possible. Probably not going into this detail. So this is what we have right now. So this is what we can say, you can start using this thing right now. But how do we actually look into the future? And here it becomes interesting with a new thing which is going to launch on Polkadot. They always say within reach or very, very soon. And that is Snowbridge. And Snowbridge is a trustless bridge between Polkadot and Ethereum. So it is basically a piece of Ethereum which is inside Polkadot and a piece of Polkadot which is a smart contract in Ethereum. And they communicate through block headers. That means that this is a trustless bridge. There's no one in between. If you want to hack this bridge, you have to hack both of the blockchains, Ethereum and Polkadot. And this is going to be very, very complicated. And it's going to solve a lot of problems that we have seen with trusted bridges in the past. So what we can do with this mechanism is that we have this identity provider on the Polkadot side, like Kilt, where you have your identity and you can share that with relying parties on Polkadot and with the apps there and so on. But you can now transport, or not now, very, very soon, transport your identity over to the Ethereum world. And then smart contracts in the Ethereum world can use this identity. And of course, the apps or dApps, which are built on those smart contracts, can then also start to use this identity. So this is a really powerful mechanism, which is hopefully going to come up soon. So this is actually the goal. So we will have Web 2 applications, and we will have Web 3 applications, and we will have blockchains. And through bridges and through RPC, we can actually connect them all. So we will have a world where we have identity providers which are decentralized, which are not for profit, which are representing your digital identity or where you hold your digital identity in a self-sovereign way, and then different ecosystems and different applications, even Web 2 applications, will be able to access these identities. And that is basically already what I had to say. Thank you very much. was too fast.
Thank you. Next, we have Marvin Tong, co-founder of Vara Network. Here's something. Perfect. Thank you.
Okay, awesome. Awesome. Hey there, this is Marvin from Vara Network, and just before the major topic, I want to share a little bit about our background and what we are trying to do. So in general, Vara is building on top of Polkadot, especially the substrate SDK, and of course we are a parachain on both Polkadot and Kusama. The nature of Vara Network is a decentralized computation network. We got a live 30K workers or servers running and providing computation power to Vara Network at the moment. But today I'm going to talk the utility and how we contribute to Web3 space besides like hardware providing. So now you can use Vara as a coprocessor for blockchains. But what does it mean, right? What is coprocessor? Is it just another buzzword? Yeah. So in the computers, there are CPUs, there are GPUs. Everybody know that. But to CPUs, GPU is the coprocessor, like chips, to help to deal with the jobs that CPU is not good at. For example, like we know, like while we are playing AAA level games, we have to have very fantastic GPU type of hardwares. That's because GPU is more good at to help rendering the 3D, the lights. So and for example, another thing is big data training for machine learnings. You need GPUs. So basically, different hardware is have their best at, and this is the concept I want to bring in, that coprocessor is like GPU, and CPU is the major chips. And for us, we think the current major blockchains, or layer 1, layer 2s like Ethereum or other EVM chains, you can run smart contract on it, right? And it's running perfect. And that's the CPU best at. But on the other hand, there are many jobs that you can barely do with the virtual machines. And that's why we think okay, Vara's best practice is to be in the coprocessor of the current layer 1 and layer 2s, so that we can help these developers on these chains to deal with the jobs virtual machine is not good at. So what is the job? Long words in short, we help smart contract on any chain to access data from any chain. So for example, you are running a smart contract on Scroll, you can easily read data from Ethereum, read data, and process the data in off-chain. Just imagine there are so many airdrop campaigns, right? How the airdrops calculating the scores. You cannot just index data. You have to calculate based on the basic rules for this airdrop, right? So those computation is running in off-chain. And that's the second party we are providing, which is compute with the data you are reading with. And then it's proof. Because without proof, it's just another backend. So we help the developers to generate proofs based on specific computation, based on the data access. So 3 jobs we are doing: help you to get access to any data from any chain and help you to compute, pretty like flexible in the off-chain, and we help you to generate it on-chain proofs so that you can use smart contract to really use this data in a secured way. So this is a basic identifier for what is a coprocessor of blockchains. This is not just our module. We think we share the same module with the other ZK coprocessors like Axiom, HyperOracle, or other projects together. Access data, computing off-chain, and provide proof. But today's major topic is not about what we already done, it's about what we are going to do in the next stage. So I'm going to introduce a new type of coprocessor of blockchains. So I know, like guys, you are in ETHDenver and you join the meetings. There's so many buzzwords, right? Restaking, AI, ZK stuff. That's what you hear like every day. But we have some different insight about AI and what can we actually contribute in short term. That is the auto agent. So you see, like this is like a growth matrix between three open source projects: Auto GPT, Longchain, and Llama. Like of course, I didn't put the matrix of Bitcoin and Ethereum, and if I put it in there, it will be you can barely see it. So compared with the growth of open source LLM, which is Llama and Llama 2, the growth of Auto GPT is amazing. It's unbelievable. So based on similar like research and insights, we do realize that people don't really directly interacting with these LLMs. They're using AI agent. So users just don't. I mean, if you are using ChatGPT over requesting the OpenAI API, that means that you are using an agent. So agents is the major interface between user and modules. So another analogy here is, I think, like application or yeah, just imagine Uniswap, right? Uniswap is an app, it's a dApp, it's a DeFi dApp. The relationship between Uniswap smart contract and the chains they are hosting on is a little bit like Jedi and the Force, right? Jedi is kind of using the powerful force, and the same analogy works in AI too. It's like if you are building an AI agent, you can just switch LLM modules, right? Today I'm using GPT-4. Tomorrow I can use another module like Sora. So you can always switch the LLM. You are just trying to gaining power to make your user like have better experience. But the agent is the software, is the service layer that how you can provide services to users. So this is something I want to highlight with. So the reason why people are using Longchain and AutoGPT is that it can massively improve the experience of user end. So without like a agent framework, how you can make sure, for example, a user how you can make sure there is a memory pool to remember the activities of user's dialogue, right? I asked some question today, and tomorrow when I pick up the conversation again, I want my AI agent to remember that. And even more, I even want this agent can improve the intelligence level based on all of my historic data input. So there are many things you can do only with AI agent framework, and that's why everybody in the space is using Longchain and AutoGPT as a framework. So yeah, just remember the fancy part of AI is the amazing module, but the nature of it is still a software. It is a software. And so now we're talking about Web3. So Vitalik actually released a blog with his source a couple of months ago, and I summarized it for childhood for children's it's 4 key insights. So these 4 key insights are actually opportunities what could be done between AI and Web3. And they're already on the right side. You can see there are many like buzzwords, tags. This means like the current project, type of projects people are building on. There are ZKML project. There are agent traders like ChainGPT. There are decentralized LLM like BTensor. There are like a decentralized compute like Akash Network. So on the right side, you can see like what like the Web3 space is working on for AI, but over there is the potential opportunity that Vitalik raised. But eventually, what we want to take is AI as the objective. What does it mean? It means that whenever like Web2 people or Web3 people are trying to build AI application, they can use Web3 stacks to enhance privacy, to enhance data ownership, or can people really own the agent itself, right? So there are many arguments, of course, from the OpenAI drama, of Sam trying to leave the team, from like the board basically fire him. The drama, the nature of this drama, I think it will just keep running like this because there's a conflict between public good or some like how if 99% of human beings is using OpenAI every day, how we can make sure they're nothing they can't be evil. There's no way you can guarantee that. But on the right side, there are already some project ideas working to improve that. We think it's not just I think. After I talk with some like projects also working on this perspective, we think there's a future that called multi-agent world. It means that agents could work with each other, like how smart contracts work with each other in DeFi Summer. So each agent could have very different, like specific tasks they are working on, and it make a very specific, service based on users' demand. But in the other hand, every agent as a microservice can autonomously, just communicate with each other and pay each other and just work together. So we believe this future, and together I think David from, for example, Autonomous, they are also like working on the same mission, and we do think like working from AI agent is better than working from decentralized LLM module. So it's kind of like like an argument, but for us, we think if you solve the problems of centralization for these AI agents, you solve 99% of the problems or trust issues for AI because users just use AI agent. So that's our thoughts. We want to build a multi-agent world like as open as DeFi Summer. So. Okay, now bring Vara in here. So what can we do, right? So what we are trying to do for now is to write up the most popular AI frameworks inside our SGX worker, which we have 30K of these workers, and all of these workers are provided by community. None of them belongs to our team, and we have variable system. So it means that this SGX system is not relied on Intel. It's not relied on hardware design. It's relied on the the tokenomic-based security assumption, and it's already alive 2 years ago. It's nothing new, but the new stuff is we are trying to just run AI agent inside it so that the Web3 users can have the privilege to access data, and use agent to deal with their jobs as freedom as possible and actually own this stuff. So you can actually own this agent instead of relying on some other third parties. And there are some key benefits we should bring to users so that there are actually people want to use it. Of course, it needs to be super easy. It need to have interactabilities like parachains or block spaces in Polkadot. So it means that when an agent receives some request, it should be able to deal with the request automatically instead of manually, and it should be verifiable. I mean, just imagine this. I don't think this use case is solid, but just imagine a use case. So you are hosting an AI agent for yourself for arbitrage, like multi-chain for profitable opportunities. You deposit like $1,000 in it, and then you tell this robot, this agent, hey, buy Fala token, each time whenever the Fala token drop 10%. Just it won't happen. But just imagine this use case. You need to know exactly how this agent works, right? Otherwise, how can you know like it's not messing around? Because if there are bugs, errors, or LLM wrong output, then your money is going away. It's very dangerous or risky moves. So you need to trust this system. And how can you do that? On this, you can verify each step of this autonomous trading agent, how it works. You can reverse, the logs. You can know, like, okay, this is my natural language input, and this is how OpenAI output, and this is how the next agent reusing this output. So this is kind of a secured sandbox, and we are trying to provide it. Yeah, and another thing, I'm going to finish very soon, but I think to make sure we can actually onboarding the AI and Web3 developers, there are two like key stuff we need to just provide. The first thing is we need to support the most popular AI tools. I personally don't believe that. People would rather to use a stupid module rather than an intelligent module just for decentralization. That just doesn't work. So we have to support the most popular modules like GPT-4, Llama, or other modules. And we have to support the most popular OpenAI framework like Longchain, AutoGPT. On the other hand, there are already a lot of popular Web3 toolings in Web3 spaces, such as Oracle API, and we just wrap it in Vara Network, and you can basically pick up your template. Do you want to build a chatbot or do you want to build a trading bot? And click, fill in your configuration, set it up. Vara is a serverless computation network. We will automatically operate it for you. So this is basically what we are providing. And the best part is you can verify it. We provide multi-proofer. It means that you can choose to verify the data or the execution result by SGX proof. It's cheap and fast. Or you can also choose ZK stacks to verify data, which is expensive and slow, but it is secure. It's guaranteed. And we are going to launch the product pretty soon. So today I'm just announcing it. And our next step is to provide a very basic templates for AI agent robots. And we are remember, we are working together with the other Web3 project who also believe and share this vision. We are now building a law. We are building together. And thank you for your time and looking forward. If you got any questions, just follow my Twitter. It's @MarvinTong. And I will just reply every DM I received. Thank you, and thank you, Polkadot, for having me. Thank you.
Thank you, Marvin. Now we have Christian Giller, Head of Research at Accurist.
Mic check. Thank you. Don't be afraid. My name is not dangerous at all. I'm also not dangerous. So that's that. I'm from Accurist. And today we're going to dance together. No, I'm just kidding. Dancing with Moore's Law. So if you have a background in computer science or engineering, you might have heard about Moore's Law. And the mobile cloud disruption that we're calling with Accurist. What is Moore's Law? So just a quick recap. Gordon Moore, one of the co-founders of Intel, he defined this a couple of years ago, this law, or more like a prediction, that the number of transistors on a microchip would double approximately every 2 years, while the cost of computers would be halved. So up until recently, he was very accurate with this prediction, but it's sort of stuck now. And the main reason is physical. So we reach like sizes of atoms when it comes to transistors. And well, I'll leave that up to the physicists to decide what's next. And also effectiveness-wise, when we talk about energy efficiency, another metric is actually much more important. And we're talking about performance per watt, which is sort of considered the new Moore's law. So you might think, why do we care about that? In a context of Polkadot especially, I'll get to there, don't worry about it. So performance per watt is becoming increasingly more important, and it's effectively just compute efficiency relative to the electricity consumption. Why do we care? Operational expenses. So as we saw in the recent years, also big tech starts to care about costs, fortunately and unfortunately. So there's always two sides of that. And also an ecological aspect. We want to prioritize decarbonization, efficiency, etc. What's the problem? As usual, 66% of the global cloud market is controlled by a few companies. And how do we connect to these issues? So we have like monopolistic pricing that is extracted from everybody who's using cloud providers. I guess lots of people that are building as of today, we have to use them one way or another. And there's a lock-in situation. We have arbitrary charges, intransparent pricing as well. And for me personally, because I have a security background, so for me data ownership, confidentiality is really important. And it's essentially impossible to achieve in a public cloud, especially when it comes to the trust we have to place in these providers. And then last but not least, accessibility. So certain countries or whole continents are more or less excluded from certain services. And this is very US-centric, for the good and for the bad. So there's lots of censorship in this regard as well. So this is the issue that we face. And how can we tackle this? So how can we tackle a 66% monopolistic market just by changing the rules of the game? And how do we change them? So that's where we close the circle to performance per watt, is by leveraging mobile hardware. Like mobile hardware, these devices are real miracles. They're so efficient. They have high performance. Most of the devices in your pockets can take it up with cloud servers. They're extremely robust and resilient and have to run for a long time, right? So additionally, what we are also really passionate about is these specific chips that we have on these mobile devices. This is an example of a Google Pixel phone here, where you have TPUs specific for machine learning tasks. We also have high security chips also in iPhones to be found, and other phones as well, where you can store private key material very securely. There's high bounties for these chips, like they're being tested a lot, so definitely special purpose and crafted specifically for these tasks. So these numbers here show that we can actually outperform server hardware heavily. We compare here comparable hardware. So we have a Pixel 7a with 8 gigs of RAM, and we have a Power Edge server that also has the same CPU more or less and same RAM capacity. And you can see already the price of acquisition is 6 times cheaper. And we're talking about a new device here. So if you go second-hand or even upcycling, it can be lower and lower. If we compare CPU mark, it's even outperforming the server. And if we go performance per watt, so the energy cost at the end of the day is 50 times less. So that's when we say we change the rule of the game. This is how we change it. The 83 times improvement there, you might wonder this is a mistake, but no, it's not. So if you actually use like a specific GPU from a specific device or TPU and have like a task defined that is optimized for this kind of chip, then you can achieve up to 83 times performance gains. So this is like huge, especially when you consider that these devices are also highly secure. Why upcycling? So we have all of these devices that are not being used anymore by telco providers, I just heard today a story of a huge consulting firm in New York. They're replacing these their phones every few years, and so they're just returning them, or God knows what they're doing with these phones. They're just maybe landing on a landfill or just in a drawer unused. So there's huge untapped opportunity here for us. We already saw, we're based in Switzerland, that like people start buying together these broken screens or phones with broken screens and start to upcycle them already. So this is already happening as of today. Here's an example. So we have a working Pixel phone, just a broken screen, and you could buy it for around $25 and can start earning rewards by providing the compute to Accurist. These are evaluations that we did a couple of weeks ago. I'm really excited about them because this actually shows or proves the claims that we have made in the previous slides. This is pure execution time, so no latency included here, and it has been run for a couple hundred times over these different cloud services. So these were cloud functions compared with Accurist. And you can see already that we're beating them here below 3 seconds. Okay. I didn't do that. Good. Sorry. Didn't want to do that. Back to the right slide. So we're beating them already when it comes to execution time. And if you think about the pricing, which is already lower as well, that's quite remarkable. Also, we have to consider that we took random devices. So since we run this a couple hundred times, we took from our pool of processors, so these are all phones distributed around the world, we took randomly phones, and on average, they were still faster. Of course, that could also depend sometimes on the specific device that you're using, but compared with the cloud functions, it always ran faster. If you're a developer and you're wondering what did we benchmark, it was the generation of prime numbers. And the beauty of this is actually not just that it's faster, but for me what's really exciting is that we can actually prove with a signature and an attestation that this was executed on a specific device at a specific point in time, and then also returned to the executing developer, party, consumer. So it's actually end-to-end cryptographically verifiable, which is not the case with the other cloud functions. So what are you waiting for? Get your old phones out there and onboard yourself. So if you have an old Android phone, then you can just scan a QR code, onboard the device, and then start getting rewards from the Accurist Canary network. In the future, we'll support also other platforms, but we're very prone to keep it as secure as possible. So the hardware needs to provide certain standards and chips that can provide, for example, HSM-like capabilities. So for example, the secure element in the newer phones, iPhones, would be an option as well. So yeah, stay tuned, and looking forward to chatting to some people later. Thank you.
Okay, up next we have Tadej from Apelon.
Correct.
Yeah, you can do either one. And then make it full screen, and then they'll put, oh, there it is, perfect. Quit.
I'll quit this. Awesome, I'm ready to go. Hi, everyone. Today I'm going to be talking a bit about building Web3 with TypeScript powered by Apylon platform. So first of all, for those of you that don't know what Apylon is a Web3 development platform that abstracts away complexities of blockchain, of parachains, of different decentralized protocols, and makes it easy for developers to come in and just do their thing. And I'm just going to go through a few features here that we provide. First is decentralized storage, which is powered by cross network, IPFS. We give developers IPFS gateways, etc., and make this really simple, drag and drop. We offer decentralized hosting. We give you an SSL certificate. This is just an extension of IPFS, so you can host your whole web page in an unstoppable manner. You can do NFT minting. You can do a normal ERC 721 collection, a Remark nestable collection on Moonbeam, on A-Star. You can check it out, and we'll be expanding chains on this. And these are maybe the features that those who know us know that these have been around for a bit now and are quite ironed out. But we were busy, and we added quite a bit stuff in the last months or so. First of them is integration of sub-social. So with a few clicks, you can generate your own chat room and integrate it in your web page, all without needing any sub-social tokens or anything else. This is also true for all the other services. With sub-social integration, we have also identity. So you can fetch sub-social identities and Polkadot on-chain identities for substrate wallets, and authentication as well. So we have authentication SDK, so you can authenticate an EVM or substrate wallet easily. We also now finally included some compute power powered by Vara, which is not general purpose yet, a specific purpose for encryption, which is NFT gated. So only people with specific NFTs can access files. And everything for this, we have a TypeScript, the point of this presentation, SDK, and CLI to make this easy for developers. But what I want to focus on today is pre-built solutions. So even though we simplify this development process, we want to go one step further. So we developed a few different pre-built solutions. These are basically full-fledged apps that leverage Apylon and all our APIs and showcase how this can be done for any developer. Meaning existing developers can come, fork the code, make a few adjustments, and bam, they have their own thing going on. Or they just take the parts that they're interested in and integrate it into their own process, app, whatever they're building. And these pre-built solutions are made with Vue.js on front end, on the back end, Next, Express, and Node.js. So really, let's say, simple and to the core, so anyone can just take parts of the code that they want. And one of the solutions I want to showcase a bit today is, like, if I look to the audience, there's a few people I know, but most of you I don't. And because you're here and listening to me babble, I want to give you a NFT. So I have no knowledge of you. I don't know your wallet addresses. So how can I give you a NFT? So this is a pre-built solution that addresses that. It works in a way that you have a backend that gathers emails and sends emails out so that you can then connect your wallet and claim an NFT, and that is an airdrop, so it's free. And this is powered by Moonbeam. So in this case, I want to showcase a bit. First of all, this is the GitHub code for this. You can see it's forked, and I did a few changes, and I'll go to it. So hopefully there's many developers in here that will find this interesting. Next, I'll just go through a bit through our platform. It got a bit of a redesign and revamped, so go check it out. I have a hosting setup. This is the service I was talking before. I have a domain setup to it, and this pre-built solution will be deployed here on this domain name. And if I go to the code itself, you can see it's a backend, a front end, and a GitHub workflow. And if I go through the workflow, you can see how easy it is to build and deploy a website and make it unstoppable. It's basically just installing dependencies, generating the website, and with a literally 5 lines pushing it to Apilon, and Apilon does the rest. So this is the first part. The second part is, well, I want to give you NFTs, so I need an NFT collection. Bear with me, the internet is not the best because I'm on a hot spot. Go, go, go. Live demos. OK, so I already have one set up, a collection for this, but I want to still showcase how I've done this. So first of all, I have a CSV ready with information for this NFT. It has the basic things: name, description, image. I have 100 of the same NFTs. There's not 100 of you here, but so maybe you can claim a few for yourself. I could have more attributes here and set them out later, but for this demo, I think this is more than enough. And if I go through, I just select this CSV, proceed. There's no additional attributes, so I'll just skip this part. And I'll upload the image for the NFT, and I can already preview the NFTs that will be created. Now I have to set up my collection. Let's say I want the generic collection. This is ERC 721. I want it on Moonbeam, and I'll just do a test here for the name and the symbol of the collection. Next, let's see how this NFT behaves. It has a limited supply of 100. I want them to be soulbound, so you can't transfer them around. I mean, others weren't here. So I'll say this is soulbound. There's no royalties since you cannot transfer it. I cannot delete it from you, so they're not revocable. And this is now my final preview of each specific NFT. Now, since the image is the same for all of them, they're all the same, but still, this is how they will look like. And I can go to deploy to blockchain. Now I have it already set up. What this does is first deploys a collection on Moonbeam Network. Second, creates JSON files and stores them on IPFS, stores images, and connects everything together. So in the storage, I already have this bucket that has the content of the metadata. And then I go to the setting up my backend. So this is the backend, like I said before, is in Express.js. And it's made so that I only need to configure a few things, like in my environment, I need to set up who the email sender is, the Apilon key, which collection it's minting, etc. And you already have Docker files, Docker Compose, proxy, so that you can set up your SSL. And in this case, the pre-built solution will be running on DigitalOcean. Now, this part is, we're here talking about unstoppability and decentralization, but this will run in Docker. But let's be honest, most of the dApps need some kind of centralized backend for parsing, etc. And in this case, I'm the one issuing you an NFT. This part of me issuing does not need to be decentralized. The NFTs themselves and the data and the website needs to be. But even imagine looking forward a bit, You had presentations before from Fala, from Accurest. You can see this running on those networks with a decentralized and a trusted execution environment. Or there are other projects that are tackling this. So even this, if you imagine a bit, will be possible quite soon. So you already have everything ready to be fully decentralized and unstoppable. Now let's look on how the pre-built solution itself looks like. So it's a pretty simple template. Here you can sign up for an airdrop, input your email, verify that you're a human. It has a CAPTCHA, so bot preventions. Now, hopefully, yeah, go internet. I'm able to solve this CAPTCHA. They're getting harder and harder. OK, I am a human. Now, if I try to sign up, I already claimed one for myself, so this should not go through. Yep, already signed up. But what this results in is a mail like this. So mail to claim your NFT. And I can, of course, this is, users add their own text here. I can link this to now. And let it load. Great success. I can claim my airdrop. Well, I already claimed it. So in this case, come on. Right. Detect my wallet. Come on. Well, live demos. Well, anyway, you can try this out yourselves because, like I said before, I have a. Oh, OK. Now I'm OK. OK. It asks for a signature, so I verify my wallet. And now it will say I already claimed because I claimed and showcase my NFT. In a while. Yeah, already minted. And here's my NFT that I have. Now, if I go back to the backend code, all of this is here in simple routes so that users can take it. It's all in TypeScript. So you can, the claim code is here. You can see how identity is verified through our SDK. You can see how an NFT collection is set and minting is done, how the response is, how the front end reacts to that. Everything is set up. And like I said before, check it yourself. Scan the QR code, claim the NFT yourself. Hopefully, your internet is better than mine. This is fully decentralized, powered by Moonbeam, Crust, IPFS. And at this point, not only go check this part out, but check out our platform. Because I'm proud to announce that every developer that uses our platform will be able to claim an airdrop. So we're incentivizing developers, builders, to see what we have, give us feedback, host your web pages decentrally, create an NFT collection, make a chat with Grill Chat, make an identity via Kilt. You can do all that through the platform and earn with that. Earn Nectar tokens. And with that, I will end my presentation 10 seconds before my cue. Thank you very much.
Okay, guys, now we have a teeny tiny break. We'll have 15 minutes. You can all grab some pizzas and sodas and water, and we'll be back in 15. Thank you. Hello. Hey there, guys. We're back. If everyone wants to grab a seat, we're gonna be up next with Cess. So just fill it in, and we'll be back soon. Let's welcome Nicolas Salastani, co-founder and chairman of CES.
Thank you so much. Thank you, Polkadot. This is awesome to be here. And I was just sharing in the back, with Bitcoin at 62,000, where is everyone? Anyway, it's great to see all of those out there. And I couldn't be more excited to be here today. What is happening with Web3, what's happening with data value, what's happening with taking our ownership back of our data is happening as we speak. Thanks to all the great technologies that are out here, thanks to Polkadot. And today I want to focus in on basically this whole concept of data value networks and the importance of them to get our data back, to keep control of it. And so where do I come from? Well, you're looking at an OG, but not in the crypto space. OG in the database space. I was one of the early people at Oracle, and so I did the Oracle database. And then there was the online cloud database. And today, we now have the decentralized ecosystem for sharing data, sharing content. And I'm going to be sharing with you today what we're doing specifically. So, if this will work. So pretty much everyone knows this slide, but the big thing here for us is it's all about read, write, and own your data. And that is so important. That is how we will go forward. The impacts out there are so critical to the crazy amount of data that is out there today. We already knew about derivative data, all of the webcams and all the collection devices, but the big thing here, of course, is AI. And if we don't own the data, the AI modules, the AI algorithms will be controlled by centralized organizations, which means they could feed whatever they wanted out of there. And by having a true decentralized system, we are going to not only own our data, but really own our future with AI. And of course, this whole world of DePIN, we'll get into that in a little bit, we'll be touching on that too. So as we look at a data value network, our data value network, it is all about that ownership. You're going to hear me talk a lot about security because that's so important. And it's not just about owning your data, but making sure it doesn't get to people that it should not get to. And most importantly, that we're able to manage that whole process. I come from the enterprise. We have to think now Web3 in the enterprise. That takes a lot more responsibility. That takes a lot more sophistication in the way we build these systems. And it's super important that we all work together to having that type of solution. Now, I talked about enterprise level, DApps, but it's also the speed in which we get the data. We cannot have systems that don't do as well as the past systems. We have to exceed what has happened in the past. And so we can have all this new functionality with Web3, but without having the systems at the same speed, at the enterprise level in terms of reliability, no one is going to, in the big corporations, want to move over to this type of environment. And that decentralized, which we've talked about being so important, has to have multi-party participation. It has to be anonymous. And we got to be able to, again, control that data and own that data. So specifically, as we look at CES, most of you know we're a decentralized storage solution. But we also have our own blockchain. We also have a decentralized content delivery network. And it is the combination of all those that brings together the data value network that we provide out there in the marketplace. Now, I'm not going to get into super details, but you're going to see here, it's a very sophisticated, layered architecture that we provide. We do make it available. We are chain agnostic, so we're able to work amongst all the different chains. And we have the APIs that allow you to get in and out of our ecosystem very easily. But in terms of the distributed storage and the distributed content layer, we actually have 4 types of miners. So you can actually be either a storage miner, a consensus miner, a cache miner, or a retrieval miner. And all this provides a super well thought out, detailed solution that echoes the likes of an Oracle or an Amazon Web Services on the blockchain. And so then we can plug into the app layer so we can really have those enterprise apps that we want that will be used by companies and they can rely on the system to be working. So specifically, we've been challenged, and these are some of the challenges we face: the data vulnerability, the inefficient storage of data. Many systems, distributed systems out there, if you have 4 storage nodes, just to make it simple, and you have each one of them having 2 terabytes apiece, the total system is a 2 terabyte system. Well, in the world of SES, we think about optimizing that. We're now looking at that 4 times 2 being an 8 terabyte system as an example. So we really maximize the storage. We have that high level of data assurance. Lots of systems today, they're good because they work, but they're slow. We want things to be, we don't need them instantaneously, but we certainly want to stream video. We want to be able to get anything quickly that we need. And so that fast retrieval, that high frequency is very, very important. And then we have to be thinking that for these systems to work effectively, they have to work in the enterprise. They have to be available in the commercial use. And so data sovereignty, the whole protectivity, the whole privacy, the whole security systems have to be in place and really allowing it to be widely acceptable for most commercial use. We go on to CDN and we think about, okay, how does that content get delivered around? And this is a key area. It's high cost. A lot of solutions out there, it's just one provider providing the CDN. You have high security issues that you have to be on top of, and we're challenged with the way that the data is transmitted and how the network gets congested. So all these things tie together, and of course, no standards yet. These are things we all have to work at. And so SES's solution is to provide that decentralized open resource. One of the key things for us is we're not an ecosystem by ourselves. Like Polkadot, we want to plug into everything. We want to allow everyone to be part of our ecosystem. So having the ability to easily, through our APIs and through our open system, you can plug into all parts. In fact, one of the key things is all of our partnerships. We have partnerships with Amazon Web Services, Google. We have partnerships with Polkadot. We have partnerships with everyone out there, and we're very focused on providing those partnerships. You can go to our GitHub. You can go to our website. You can see all the different ways to get involved with SES. We have all sorts of programs that will allow you to easily figure out how you can take advantage of our full ecosystem. And so, that is a critical component because for this all to work, we have to be working together. And, when I was flying over here from the East Coast just yesterday, it just so happened the guy next to me was head of the Oracle Navy implementations. This is a guy that runs all the Oracle systems out there for the Navy and travels the world. And, of course, it was one of those, we're just about to land stories, but in that 15 minutes of talking, Navy and a lot of organizations are so challenged because they want to own their data. They don't want to go to the cloud, but the cloud is, much easier to work with. It's faster, it's more efficient. So are they going to trade off? Is the Navy going to trade off and let that information sit in a cloud, or are they going to keep it in the Oracle database? And he is, in fact, looking at Web3 to actually jump past the cloud and come into a place where they truly own the data, which is very exciting. This is the stuff that's happening right now as we speak. Organizations like the Navy, I've talked to the IRS, other governmental agencies, certainly the corporations. PwC has lots of work they're doing right now in implementing Web3 solutions inside corporations. So it's super important to be able to have the systems that deliver a high transaction and really well-toned system. So now the testnet, I want to thank everyone in the room that has been on our testnet. We're in our 13th release of the testnet. We've had over 40,000 nodes in the testnet, and it's over this past 2 years that we've actually worked with a lot of you to perfect the system that we're providing. And it's through that exchange of information. Remember, we're big on Discord, we're big on communication. Follow us, keep involved, but provide us with your insights, because it's us all working together that's going to make this all work. And so we just launched out the latest 0.76 release. That came out the end of January. We already have 2,300 nodes up. As I said, we've had nodes typically, we get about 6,000 to 7,000 per release. So all the feedback is greatly appreciated, and we are getting close to letting this run on the mainnet. So we're getting to that golden release time, which is extremely excited for us. We are a token. You can, basically, we'll be issuing tokens. Some of you might know that we just announced the close of our first round of $8 million, and we just started this past week a new round to expand our horizon here. So this is, I think you got a sense from the layered slide, this is a very complex solution, and I spoke this morning at a DPIN group, and if we think about DPIN, it is all about allowing us to interoperate through APIs, letting everyone play, developers, miners, users, enterprises, and so we have to allow for all of this to take place. And you'll see all the 4 different miners that are up there. You'll see the exchange of data. You'll see the exchange of basically the consensus security. You'll see the exchange of tokens. And bottom line, all this you can find on our website at ses.cloud. It gives you a lot more detail than what I have up here in the time I have to present to you guys. But fundamentally, this is a very, very sophisticated system. And for us to win at DPIN and win in this world of Web3, we have to elevate all of our systems together to ensure that we really have something significant. And so we, as I said earlier, don't count on just having our own ecosystem. We have to think about being in the ecosystems that are out there. And so, interoperating with all the different ecosystems here is absolutely critical, but it goes beyond that. Think about in technology, it's always about being available and going back in time, being able to utilize all of the solutions from the past. So that means that Web 2 and Web 3 have to interoperate. In fact, the guy at the Navy has to interoperate with his Oracle database into the Web 3 environment. And so we are seeing that as a very important part of this. And what makes it really interesting is that we can, through SES, actually connect a AWS cloud to a Google cloud. So we are now looking at Web 3 as being the glue amongst all the Web 2 and the standalone systems that are out there, which make that extremely exciting. Probably for me personally, being a member of IEEE, I don't know how many of you know IEEE. It's a standards organization that has been out there for now 140 years. Standards are very critical. If we think of just sidetracking for a minute, IoT, was having a really big challenge until some standards came out. So when Matter came out, it made life amongst Apple and Amazon and Google a lot easier. We are going to have the same thing, the same challenges in DPIN and Web 3. And so what we did at SES is we actually formulated the first decentralized storage IEEE standard, and that is now out there for discussion, and we want to push that initiative forward to facilitate the interaction of all of us as we work together. And the last thing is, take a shot at that QR code, because that will give you everything about us. You'll be able to be part of our story. You can learn more about SES. You can get to the GitHubs and follow us on Twitter. You can actually communicate with us. We have evangelist programs. We have all sorts of programs you can participate at. And most importantly, stay abreast of what we're doing. We're about to announce some very big things over the next couple of months, and we'd love to find ways to work with all of you. Thank you.
Up next, we have Shubham, Head of Ecosystem for Manta Network.
Cool. Yep. Hello, everyone. Thank you for joining, and thank you, Polkadot, for inviting me. So my name is Shubham. I'm the head of ecosystem at Manta Network. So, yep, let's start with it. Talking about Manta, so just to give you a very brief introduction about Manta, Manta is a layer 2, plus it is a layer 1 parachain on Polkadot. So we have a layer 1. Initially, we launched a layer 1 back in 2020, which was a kind of privacy layer. After that, we thought maybe we'll launch a layer 2 as well, where in future we can connect both the layers together so that we can have a layer 1 as well as a layer 2. So that's a brief introduction about us. And by the way, like, I'll majorly focus on what Manta is right now, how we are working on the L1 of Polkadot, and what we are doing on the layer 2 side. Plus, very brief about how infrastructure is working right now on Manta, and how the developers or the dApps who are currently working, how they can closely work together to build a good ecosystem. Cool. Let's talk about 3 key major success reasons why Manta is currently doing great and how we are performing this together. So first is about the productization. Second is modularity, and third is service. So first, let's talk about what is productization. So it's regarding the technology and the product. So the product definitely is Manta Network, and the technology which we are currently using is modular. So right now, if you know, like, Parachain was initially launched, as I mentioned, as a privacy network. After that, we shifted to layer 2, which is another technology, another ecosystem. But right now, with the help of technology and recent growths, we are trying to connect both the chains together. So we are doing that really great. Right now, it's around, like, back in September, we launched our L2, and we were live on the mainnet side, and it's around 7 to 8 months, and we are really doing good. It's around, let's see, I'm sorry, the numbers are quite not visible, but it's around 875K wallets, like, already live on Manta. It's around 46K transactions doing every day in last 24 hours and stuff. Cool. Let's talk how the technology is quite unique, because you might have heard about all the layer 2s right now, and it's going boom. Like, not just EVM, but Bitcoin layer 2s as well. So let's talk how we are quite different from any other L2 right now. So we are using Polkadot, Polkadot for the layer 1. On the on the L2 side, we are using OP stack. So we are a OP stack right now, but soon we are going to shift to ZK with the help of CDKs of Polygon. So that will help us to shift the whole technology, or whole the stack which we have right now, which is OP, to a ZK, which is our new narrative right now. Next is about the Celestia. So as you know, like, Celestia is a part of an ecosystem, and we are the first chain using Celestia as a data availability layer. So back in December, they launched it, and we are the first chain. On the day 1, we launched, and we successfully using them, and it's going good for the ecosystem as well as the gas fees which we are using right now. This is the current ecosystem of L1 plus L2. So we have around 312 projects already onboarded on both chains, L1 and L2. Right now, the major dApps which we have right now are on the L2 side. we have infrastructure projects, DeFi, gaming, social and identity and NFT side. But the major part which we hold right now is on the infrastructure, and second is on the DeFi side. So there are some big projects like the projects which are quite big on Manta is QuickSwap. On the lending side, it's like Layer Bank, Surebill, ZeroLend. Okay. Uh, I know like you guys are quite good on the technology side. I think like there will be a lot of people who will be better than me on the technology because I'm from the non-technical background. But yeah, let's discuss like how Manta is connecting to the modular stack. So if you know like on the initial chains which we had, they had a lot of problem on the scalability. They had a lot of problem on the data proofs and stuff. So that's how like we started. So back in September when we launched the chain, we were quite focused on the ZK side. But the ZK technology was not that great. The gas fees was a good, like high, and we couldn't adopt the mass adoption with the new chain. So that's the reason we initially started with the OP stack. But soon, as I mentioned, we will shift to ZK with the help of CDK. And we wanted to do the low gas fees on the ZK side. So that was the reason we initially deployed Celestia, like integrated Celestia. And after that, we moved to like CDK, and by like maybe 1 or 2 months, we will be live on the ZK technology as well. And by the way, that's the main good thing. Like for example, right now you are a DApp already live on Manta Network on the OP stack. In case in future, if you go to like we shift to ZK, you don't have to worry about anything. It will be already live. You can easily do everything, and it's like great opportunity for you to shift from a technology which is like OP stack, which is one of the biggest right now, to a new technology which is coming as like ZK. So the second pillar of success to Manta was the service which we give. So actually, I think like I won't go on the deeper like technology or part. So I'll just give you very simple examples. There are a lot of L2s right now. Some of them are kind of institutions. Some of them are kind of corporates where they doesn't perform as a Web3, but a Web2 kind of thing. So for example, if you are DApp, you want to support, you need to talk to 3 people initially, then you need to get the support, and then you get the grants or stuff like that. So it's a very complicated or a grapevine process. But at Manta, we don't do the same thing. So just a very simple thing over here. So right now, if suppose I'm the head of ecosystem, I'm talking to around 800, 900 projects. But that's the good thing. Like our co-founders, our CEO and CEO are in every group which we have right now. They are supporting each and every project, even if they are really small, tier 3 project or a tier 1 project right now. So that's a kind of service which we are providing. But apart from that, let's go to how the community members and how the team looks like. So initially, as I mentioned, we were not just focused on any one globe or, one state or one kind of country. We are from, like, we have users, which I mentioned, like 875K wallets from 100 plus regions. Our team members are from 15 plus regions. By the way, I'm coming from India right now just for ETHDenver. And next is about the regional support. So that's the major thing right now. So for example, there are a lot of regional communities which don't usually speak English, but they have a lot of issues, and we usually prioritize the dApps plus the community which we have right now. So that's how like we are working. We have 10 regional communities, 2 are in process right now for the European countries, but we are trying to cater all the users from different places. So whenever you face any issue, you don't have to worry and wait for a long Discord ticket to just get a simple reply. That's really simple. You can just log into, you can just go to the Twitter pages or maybe the Telegram pages and just find the answer for every question, whichever you have. And we are open for the suggestions as well, even if you are a community member. Let's talk about the growth which we have right now. So just to mention, it's written as 1.5 billion, but right now it's around 1.8, 1.9 billion TVL on Manta Network. Major is coming from the DeFi lending protocols. Second, we are the fastest growing L2. So as I mentioned, we launched back in September, the L2. And right now, I think like it's around 7 months, and we are the fastest growing. It was around 587% average growth. Apart from that, the addresses are around 800K. We have around 12 million plus transactions right now. We are the 3rd largest chain in whole the ecosystem after Arbitrum and Optimism. And yep, the already live project specifically on the L2 side is around 180. Cool. So as I mentioned previously about the Celestia, and we are like using them. So I'm sorry again, the screen is not visible much, but it's okay. So we have till now, like back from December till now, we have saved around 1.8 million in gas fees. So that's how like the Celestia and the data availability is using. By the way, there is a fun fact. So we have a Explorer right now from Block Scout, and we have another Explorer specifically for data like availability fees calculator, which is from Social Scan. And the more users or maybe the more projects visiting on Social Scan is more than the Block Scout, because they are more interested on the DeFi, the data availability gas fee saving part. Cool. Yep. So this is the growth. As you can see on the L2 beats, we are the third one. After Arbitrum and Optimism, it's around 1.9 billion on chain TVL. And it's going good and well. We recently launched the token as well back in January. Before that, it was around 1.2, and after that, it's been going up. And because of the good market standards, I think it will go again up. So yep. The major, like out of 180 dApps deployed, I want to focus some of them. So Layer is one of the biggest DeFi lending protocol on Manta. They have initially started with Linea and other chains, but right now, on other network, it was around 6 to 20 million TVL. And right now on Manta specifically, just one lending protocol holds more than 635 million TVL. That's how big they are right now. And the second, the fastest growing lending protocol, which we didn't support, but still they are doing good. And right now we are trying to give them more and more opportunity, which is Zero Lend, which has around 18 million TVL in just few days. It's not even weeks, it's just few days or month. Between a month, they have grown to 18 million. Yep, this is some of the recent updates which we did. So as I mentioned, the first one is about the total DeFi ecosystem or the DEXs which are on us, like Izumi, QuickSwap, Aperture, Pacific Swap. We launched our recently token on all the biggest tier 1 exchanges, including Binance, KuCoin, Bybit, everyone. Apart from that, we like back in on 25 in January, just after launching the token, we already had all the dApps already verified. 1,000 plus smart contracts verified. Daily transaction was around 150K. Right now it's a bit low because of the more liquidity, more locked in because of the lending protocol and some campaigns. And there are around 800K plus users. Also, like as I mentioned, we are recently looking to the ZK side more and on the ZK narrative. So we have recently launched an accelerator program with some biggest like names like Polychain, Celestia, 7x, Polygon, and stuff. So we are majorly focused on all the ZK applications or maybe fully on-chain games and stuff who wants to build on Manta, or not just Manta, but they require some support on maybe early stage building an infrastructure or maybe building a dApp. So that's how like we are working right now. Just to mention about the team, so we are around 60 plus team, like the core team. Apart from that, we have some community managers. Our co-founder, there are two co-founders. One is from Harvard and one is from Massachusetts. Cool. Before ending the topic, how and what things, I would like to mention few things like how and Manta is currently working on L1 and L2. So after the token launch, so just to mention, like we were initially a privacy network, but that time ZK technology was not that great. And I'm talking about back 2020 and 21. So that was the reason the network was not performing well. But after the token launch, we are trying to connect the L1 and L2 with the help of liquid staking firstly, so that all the token holders who are holding tokens on the L2 side, they can do liquid staking of Manta token directly on the L1 side, and they can earn some passive income out of it. Apart from that, on the specifically other L1 sans L2. So we are trying to get more DEXs and more things on the L1 plus L2, so that the DEXs who are currently on the Polkadot or maybe on the Manta Network Pacific L2 side, they can just build on it. We are trying to create more ecosystem. And also, yep, that's pretty much about us. Thank you so much, guys. It was great meeting you all. Thank you.
Okay, now let's welcome Marta Damche from Subsquid. Subquery.
Great beginning. Hi, everybody. Thank you so much. Let's set up. Hi, everybody. I'm Marta. I lead business development and subquery. I am a little bit jet-lagged, but happy to be here. We flew from New Zealand to be here, connect with partners, builders, customers, so we are very excited to be here. And for this particular event, we wanted to discuss multi-chain indexing, which is one of our core features, something we believe brings a lot of value to builders, and we think this event is just a perfect occasion to discuss multi-chain indexing challenges and also see how subquery helps builders overcome them. And this is the topic of this talk. So to start with, what subquery is. Yes. We are an open source, flexible, customizable, fast indexer. You can think about subquery as an API for customizable API for your DApp. We help builders get data from chain in a faster and more efficient way. Blockchains are solving a lot of issues for builders. They're bringing a lot of development and changing the world, but they're not designed for querying data. So this is the problem we are solving. So we're trying to help builders focus on their end functionality and have access to the data in a fastest possible way so that they can deliver great experience to their users. But we also want to not only focus on user-friendly application, modern application, but also developer-friendly environment and developer-friendly development processes. So that's why we put a lot of efforts into it. And what indexing does, and what subquery does essentially, it allows you to get data from the chain. It saves it in a database that you can then query through GraphQL API endpoint. And as you can see, we can work with any project. Like essentially, if you need some data from the chain, you may need indexer. You may build it on your own, but you can use also solutions which are available out there and focus on building your own project and functionality for your users. And we support many networks. I will talk more about it in a second, but we also work with projects from different verticals. You can use indexers for applications like analytics applications like blockchain explorers, but also for narrow down use cases. And we have users who are building the apps from any possible vertical, from NFT marketplaces, through social-fi, DeFi, gamify, so a lot of different use cases. And we are happy to be faster than the graph. We monitor it closely. Performance is key factor for us. We also have a lot of features that make projects built with subquery unique. So we allow historic state indexing, real-time indexing of unfinalized blocks, indeterministic indexing. We are very flexible and have a lot of cool features. So just take a look on our documentation. And as I said previously, we do support a lot of networks, and it's currently more than 150. Polkadot is our mother ecosystem. This is where we started, but we quickly went beyond Polkadot to other ecosystems like Cosmos, EVM, of course, Near, Flare, Stellar, and many more. And to give you an overview, here are some of the biggest, or like we thought most important changes that we wanted to feature, but here is the link to all the current state of our support. And if you are here and you're a part of network team, make sure to reach out. We are here and would love to bring you on board. We made it fairly easy for our developer team to bring support for more chains, and we'll be definitely growing. We believe in multi-chain future, multi-chain projects, so that's why we put a lot of effort into bringing support for new networks. And then going to issues related with multi-chain indexing. So essentially, blockchain space is hard. The tech is complex. And personally, I'm coming from Web 2. And I was working for many startups, and the pace is fast, but the pace in blockchain is completely different. So to stay on top of what's happening, or stay on top of new technology, and who's building and on what, it's self-hard. So that's a problem. But then we also observe a growing tendency of blockchain becoming more and more specific, like application-specific chains. Polkadot itself, Cosmos zones, Avalanche subnets, Optimism stack. And this is great for use cases. This brings a lot of value to ecosystems, but it also causes a problem for developers. So there isn't data incompatibility. You're dealing with different RPC interfaces, different API protocols, data handlers. And if you want to index data from different chains, you will need to build different indexing projects, and you will need to unify this data somehow somewhere in your application stack to be able to power up your application easily. So this is something that can be solved for builders, and this is exactly where subquery shines. And also we are in the position to partner with many projects as a tooling provider, and we talk with many partners and customers, and we see that this is multi-chain use case. It becomes more and more important, and is like a key requirement for new emerging projects. So definitely, this is the future. And subquery built a solution that allows you essentially to index data from different chains, but into one database, which you can then query through one single endpoint. So this solves a lot of issues that I have mentioned previously, and this is truly write once and run anywhere solution. And you can index data from sources like EVM, substrate-based Cosmos within one project, and have the data shape tailored for your project, for your application, and then you can easily digest this data and solve the issue of data incompatibility for yourself. And behind the curtain, subquery actually runs many like separate indexers. So we have each node for every chain you want to index, but then we save it all in one database, and we provision this one single GraphQL API endpoint for you to query this data. And then to show you some examples, because it's a Polkadot context, so let's think you want to do some analytics for cross-chain messaging transfers, and you are looking at one parachain, and you want to index the transfers going to smart contract, which resides on a different parachain, which is EVM compatible. This requires for you to make two separate indexing projects, and then possibly, not possibly, but for sure, separate tables and maybe even separate databases. And then you have to work on querying, you have to work on unifying this data so you can then use it within your application. And this is something you don't have to worry about with subquery. And essentially working with subquery, for you it's changing 3 files. So for the schema file, this is the file where you define your objects in your database. A manifest file is like a configuration file where you are able to define what and from where you want to index. And then mappings file, this is where magic happens. You get data from the chain in a payload of your function. You do some logic, transformation of this data or not, and then you save it in your database. For multi-chain setup, you will need to enable it. You can do it either through command line or in the project itself. And then for each chain, you would need to have a different manifest file. And the rest should be the same as for single chain indexing. But don't worry, we made it simple for developers to actually get this different manifest file for every chain, so you can do it with one command through our subquery CLI. And for more information around how it works, check this guide, which is here. You can access it through the QR code here. But I will also show you quickly the project. And the project that I want to show you indexes transfers across Polkadot, Kusama, and Asset Hub. And here you have a code to the project itself on the left side, and on the right side, there is like a longer blog post explaining everything step by step, why we are doing it, why it's important. But I want to show it to you, so let's see. Not sure how much time I have. Okay, so this is this project. And here, as I mentioned previously, I want to show you that we provision 3 different nodes, each for a certain network. So for this project, it's Polkadot here. And then we have Kusama. And then there will be Asset Hub here. And they all point to the same database. So this is important. So 3 different nodes, but saving data in the same database. And then I've mentioned schema GraphQL. So this is the file where I want to start. This is essentially where you define the data shape. So this is the result of your query. You will get data in this shape for this project. And it's all customizable. You can change it as much as you want. And this will be the same shape for data coming from every chain in this project. So this is pretty cool. And then want to show you one of the manifest files. For multi-chain project, we also need this file that references all the manifest files. Usually for single chain, you won't see it. And then let's say, for example, Kusama. So this is here our configuration file. And the top part, it's not that important. Where I want to focus is here network. So this is the place where you define from where you want to index, essentially. This is all adjustable, so you can change it. And this is the place where all the 3 manifest files in this project will vary from each other. Essentially, for more of the use cases, the data sources will remain the same. And in this part of the code, you define from where you want to index. So here we have like the first block, but it can be any other. And then in the handlers, you define what type of data you want to index, what type of events, which module, which method. You can be as specific as you want. And there are more than 1 handlers to be used. And this handle Kusama event will match with a function in mappings file, where we go right now. And this is the last file I want to show you. And here we go. So we have handle Kusama event. So this is exactly matching the handler from the manifest file. And what happens is that indexer goes from this block first that we pointed to, and then goes block by block and checks if there is an event that matches our filters. If it does find it, then it will execute this function. And here, this function actually points to another one, handle event. And as you can see, it's the same method for both Polkadot and Kusama handlers. So that's why this is how it works. And within this function, we do like a complex logic, essentially checking if a certain account exists or not, doing some other operations. But most importantly, we actually populate the properties of this object with data that we got from the chain, and we save it in a database. This part of subquery project is quite flexible. So you can use external APIs, libraries. You can call another application. You can trigger something else within your application stack from this moment. So, and you can imagine getting some data even from off-chain context and be able to actually enrich your database with this data in that specific moment. So this is pretty powerful. And this is the third file you usually work with when using subquery. And then what you will have is that you can host it locally. You can also host it with us. So make sure to check our documentation for our managed services. But we provision GraphQL API endpoint for you to query the data. And here is this project deployed for us to see how it would work. So essentially, you will just get the response to every properties of the object in your query. And this is, of course, up to you how you query, and you can use GraphQL language to query this data. And then going back to slideshow. If you need more information, feel free to check our documentation. We put a lot of efforts in updating it and making it as actionable and valuable for developers as possible, and also join our community. Get inspired by others, learn what others are building, and our team is also present there. We have a busy technical support channel with a lot of cool questions, so feel free to also come along there. And thank you so much for being here. It was a pleasure. And we are here for the whole week. So make sure to get in touch. Here is my Telegram handle. I'm happy to discuss subquery in detail, learn about your project, and see if we could be a great fit, if you could use subquery. Or if you are a network team, if we could onboard you and bring support for builders in your ecosystem with this open source indexing tool. Once again, thank you for your time, attention, and let's be in touch.
Okay, guys. Now let's welcome Kevin Nielsen, Developer Relations Engineer for Moonbeam.
Hello, everyone. Thank you so much for coming out early to ETHDenver. I know the main event doesn't start until tomorrow, so it's awesome that y'all are here. And I'm really excited to talk to you about connected contracts on Moonbeam. So if you've listened to some of our workshops before, you might have seen that we talk a lot about XCM. We also talk a lot about connected contracts. And so I wanted today to talk about something a little bit different than XCM, and instead to talk about general message passing. And when we talk about general message passing, this definitely encompasses XCM. But typically when we say XCM, we're talking about inside of Polkadot. And then when we say GMP, we're typically talking about Moonbeam's connections outside of Polkadot. So that includes the chains like Ethereum, that includes chains like Polygon, Optimism, many others. And so today I want to run you through an example of what it would be like to interact with another chain. And basically we'll look at some of the mechanics of how this cross-chain contract call works. So there's typically two types of transactions that you would want to make. One is just to call a contract on a remote chain. It could be as simple as sending a message. We have several tutorials that show you how to send hello world messages to other chains. But more likely, you're probably going to be calling a contract. And that could include things like buying an NFT. It could be making a swap. It could be depositing some collateral. It could be anything. Anything that you can do on a blockchain, you can make that into a cross-chain call. And we'll go into exactly what that looks like in just a sec. So another option is you could also call a contract, but also send along tokens with it. And this would be like your bridging operation. And when we talk about bridging, if you're just going to a bridge like Wormhole, for instance, and you're bridging tokens, that's a subset of general message passing. So you're bridging value, and that is just the application that you're making with the GMP provider, with Wormhole in this case. So in this example, I have a tangible hypothetical example that I want to give you. And we'll be using Axelar here as the GMP provider. Now, a lot of these GMP providers, they work pretty similarly. There are some differences, but I felt that this is a great example to use to demonstrate. And if you understand one way, then you're probably quickly going to understand how the other ones work as well. So let's say that we'd like to mint an NFT on Polygon. And the NFT mint is free and open. But I don't have any Matic tokens. I haven't set up a wallet yet on Matic. But I do have Glimmer tokens on Moonbeam. And so what I can do is I can send a message from Moonbeam through Axelar to actually buy that NFT for me. And I can have that NFT sent to the same wallet address that I own on Moonbeam, just on the Polygon network. And I don't need to go out, and I don't need to go out and buy Matic funds. I don't need to change the network in my MetaMask. I don't need to go and add some new RPC URL and switch networks and have a bunch of pop-ups. Instead, I can confirm one transaction on Moonbeam, have it go through Axelar, and then take the action that I want to take. Now, we're showing Polygon here as an example, but there's a huge number of other chains. So if you want to buy an NFT on a layer 2, if you want to buy an NFT on Ethereum, if you want to buy it on a whole host of other chains, that's also possible as well. We're just using this for the example. So there are 3 steps. There's the destination chain, there's the Axelar network, there's the origin chain, so that's Moonbeam, there's Axelar, and then there's the destination chain, which is Polygon. So let's take a closer look at what we're doing in each step. So on Moonbeam, with the source chain, if I have a dApp that I'm creating and I want to use it to purchase the NFT on Polygon, the first thing that I'm going to do is I'm going to call the Axelar gateway contract. And the Axelar gateway contract has a couple different methods, but the 2 ones that we're going to be talking about are the call contract or the call contract with token. And that corresponds to exactly what I mentioned in the last slide, which is the 2 main use cases that we're going to use GMP providers to do. So when you call the Axelar gateway, it's going to ask for 3 simple parameters in call contract. That would be the destination chain. So that would be Polygon in this case. That would be the destination address. If we are minting an NFT, that will be the NFT contract itself. And then it's also going to take a payload. So this is the call data. What is the function that you want to call? What are the parameters that it requires? And it's going to look and feel exactly like just a regular contract call. So there's nothing special here, just the function that you want to call and the parameters. So in this case, if you are doing this free mint, you're probably going to need to provide an address that you'd like the minted NFT to go to. You also, depending on the NFT contract, you might have to specify, I want 1, I want 2. So we'll specify an amount of, let's say, 1, right? So that will be wrapped up in the payload. Now, one important thing to mention is that the GMP providers do use different chain IDs than the typical EVM chain IDs. So Ethereum's EVM chain ID is 1, Moonbeam's is 1284, but a lot of the GMP providers will have specific identifiers of their own. And you can look those up on the doc site for each of the GMP providers. OK, so just in a bit larger font, all we're providing, 3 things: destination chain, contract address, and the call data. That's it. If we are sending a token along with the cross-chain function call, we are going to have to include a token symbol and also the amount that we're sending. So this is if we use call contract with token. We're going to have 2 extra parameters that we need to provide. OK, and the last step here of what happens on the origin chain, which is Moonbeam in this case, the last thing is that we're going to have an event emitted that corresponds to the call contract or the call contract with token. And the Axelar network is going to be listening for these events. And if it picks up an event, then it's going to move on to process it and validate it and make sure that it's valid. So let's talk a little bit about how that works. So the Axelar network, as it is now, has about 75 validators. This is a decentralized set and a distributed set. And it's architected in a way that only one validator needs to be honest or just up and running. So if 74 of the nodes are down or they're malicious, we just need one that's working, and we need one that's going to pass along the call. So the Axelar network will process the call. It's going to perform a couple checks. So what is it going to check, right? It's going to check to make sure that you provided enough gas to execute the transaction on the destination chain. So let's step through that a little bit more closely. So the origin chain is Moonbeam. You're going to pay gas just like a normal transaction on Moonbeam. So you've got your normal transaction fee. But then you're also going to send along some value. And this value is just to pay for gas on the destination chain. So Axelar has an SDK, so you can calculate how much gas you need in order to send along with it in order for the call to be executed. So Axelar will tell you what you need to send along, and it will take care of the payment on the destination chain. So you're not getting Matic tokens, you're not doing a swap, you don't have to do any of that. Axelar takes care of that. And so as part of this check, it's going to make sure that you have enough. And if you forgot to, it'll say, it'll give you an error, and you'll be able to add the funds that you need, and then the call can continue. If it's approved, if everything looks good, it'll go through the process, and then it will call the gateway contract on the destination chain. And, whoops. Once it goes to the destination chain, this is step 3. This is now happening on Polygon. When it gets to the destination chain, it's going to call the approved contract call, also of the gateway contract. And this gateway contract, again, is deployed to every single network that's within the Axelar network. So we have Polygon in this example, but it would be the same thing if it's deployed onto another network as well. So approved contract call, that goes through. Lastly, we get to payload executed. And this is a normal contract call. The NFT contract, where we're doing the minting, it does not care if it's cross-chain or if it existed on Polygon originally. It can't tell. There is no difference. And this is very important because it means that you don't need to re-architect smart contracts. And it means that your cross-chain call is going to behave just like a regular function call. And so what that means is that if, for example, the NFT contract had some sort of whitelist, and if you, let's say, were not on that or something like that, if you didn't meet some certain requirements, then it would fail just like a regular transaction. So this sort of cross-chain interaction is just like a normal contract call. So with Moonbeam, you can reach any user and any asset on any chain. And we'll dive into a bit more of how this works. Moonbeam is the best place to deploy your application because you don't need to worry about, hey, if another L2 pops up and I need to have access to the users on that chain, or if something pops up overnight, you don't need to worry about saying how do I access these users? How do I access the liquidity on this chain? The reason for that is because the GMP providers are adding new networks all the time. So if Axelar adds a new network, Moonbeam doesn't have to do anything. Moonbeam is connected to Axelar, and so we're going to be connected to whichever new network that Axelar adds, which is really, really cool. So Moonbeam has a ton of different GMP provider integrations, and this is a big deal. Personally, for personal developer preference, some people might be more comfortable with one versus the other. And secondly, for redundancy. Some GMP providers do have scheduled downtime during short windows. And so you might need to have another way to get your message across during that time period. And it's always good to have a backup. So Moonbeam is integrated with Axelar, Wormhole, Layer 0, Hyperlane, and all of these are great, great options for building a cross-chain connected contract. So I want to talk a little bit more. We'll zoom out a little bit from the specifics of the cross-chain message, and we'll look a little bit more at an overview of cross-chain connected contracts and multi-chain components. So the first thing is that we've had this belief for a while, and it's that the future is multi-chain and cross-chain. And part of the reason for that is because it's so easy to launch a new chain. Tensi will be on stage in 2 talks from now, and you'll learn about how you can launch an app chain very, very quickly. And there are layer 2s spinning up all the time. And so we believe that this proliferation of chains is going to continue. And so do we want to be in a spot where users are kind of bouncing from chain to chain and having kind of a difficult experience moving between them? Or do we want to have one that's a lot more fluid that doesn't require users to constantly change their network, but gives them the benefits of accessing assets, users, buying NFTs, and doing all of this in a much more enjoyable manner? In kind of the years past, the common kind of solution to building like a multi-chain approach was to pick one chain, 1 or 2 chains, and then say like to your users, hey, we're here, come find us here. You can bridge to them. You can go and buy native tokens, and then you can interact there. But this is definitely segmenting your users, right? You're asking them to bridge, you're asking them they may need to set up a new wallet, and so that's a little bit tricky. And in another case, this kind of evolved right onto, okay, rather than picking one chain or two chains, we're going to say, let's just deploy everywhere, right? And let's deploy the same exact thing to all these different places. And for certain DeFi apps, right, you're going to fragment your liquidity, you're going to fragment your users, you might have features that are specific to one particular chain. And as you know, if you're working with DeFi, you want to have the deepest liquidity pools, you want to have the best trades, with the lowest slippage and stuff like that. And so that is enabled when you have more of a connected contracts approach. And so one of the things that you can do is you can design a kind of a hub and spoke architecture where Moonbeam is the kind of the brains of your application. And then you can have satellite smart contract logic on connected chains. So as an example, gas on Moonbeam is cheap. And so you can have more complex computation on Moonbeam, making decisions within your smart contracts. And perhaps you have things like depositing collateral, a simpler operation. Perhaps you have that on Ethereum or your other connected chains. So to reiterate, general message passing is what enables this connected contracts approach. If we didn't have the GMP providers that are connecting all these different chains together, we would have a very, very difficult time. So it means that applications on these blockchains can have more of a unified approach. They can be aware of each other. So they can benefit from liquidity on multiple chains. And so rather than having distinct deployments that don't know about each other, that don't benefit from each other, you can have a more holistic approach where the liquidity could be shared, or you can tap into assets on other chains. And one example that I want to highlight, Prime Protocol is a cross-chain prime brokerage. And a prime brokerage in traditional finance is kind of like a bank that handles the assets of VIP clients. And so if you're a prime brokerage client, you might have stocks, bonds, maybe you have physical assets, houses, boats, everything like that, with the bank, stored with them. And so you can go to them and you could say, hey, I want to get started on a new business venture. I'd like a loan. I'd like a $10,000 loan. And they'd say, well, we've got all your stocks, your bonds, your boats, your houses. Like, we have no problem giving you a loan. But in the blockchain world, it's more of a separated thing where you need to have the assets that you want to borrow against on the same chain. So if you want to borrow on Ethereum, typically you need to have your collateral on Ethereum. And if you want to borrow on Moonbeam, typically you would have to have your collateral also on Moonbeam. So let's say you have Ethereum that you wanted to use as collateral, and you want to take out a loan on Moonbeam. Typically, you'd have to bridge that ETH over to Moonbeam, and then deposit it into a smart contract, and that will give you a loan on Moonbeam. But with Prime Protocol, you can keep your ETH on Ethereum. You don't need to bridge it over to Moonbeam. You can keep it in its native form on Ethereum, and you can deposit it into a satellite smart contract. And Prime Protocol will recognize that. It will secure the collateral, so the protocol has ownership of that collateral, and then it will give you a loan on Moonbeam. And so the brains of Prime Protocol that are managing the liquidation decisions, that are managing how much collateral you need to have, all of that's happening on Moonbeam. And then in the case where you need to post more collateral, or the case where you need to be liquidated, the decision would be propagated from Moonbeam out to the satellite smart contract, which could be Ethereum, Avalanche, Polygon, Arbitrum, and there are several others that Prime is working with, and that is quite cool. And just another thing to add, if you prefer, to play around with this, maybe not on mainnet, then you should be able to play around with it on testnet. Many of these applications are deployed also to testnets as well. So For the last, right before I wrap up, I do want to highlight one more thing, which highlights kind of the intersection of GMP and XCM. So, and that's Moonbeam routed liquidity. And Moonbeam routed liquidity is a solution to get assets from outside of Polkadot very easily into Polkadot parachains. And so the idea here is that you may want to bring assets from outside of Polkadot, maybe Ethereum, maybe ones on Avalanche or Polygon. Again, many others. We're just showing 3 here just for illustration purposes. But you can bring those in through Wormhole, and all in one transaction, you're going to be doing what we talked about before, which was that a method similar to call contract with token. And once it arrives to Moonbeam, it's going to hit the GMP precompile, and it's going to be routed to the destination parachain. This happens all in one step. So it isn't going from outside of Polkadot. It isn't like staying in Moonbeam for like 20 blocks or whatever. It's the exact same. It lands on Moonbeam, and then it instantly gets routed to the destination parachain. And when I say one click, it's the typical bridging experience where you might have to do an approval one, but then you'll have your transaction confirmation, and you'll specify the destination just like you would on any other bridge. So you may not have to worry about like what's the destination parachain. You may not even know that it's going through Moonbeam and then going to Polkadot. So going to a Polkadot parachain. So you'll just have the destination as Hydrodex or whatever the parachain is that it's going to. You'll select that on the interface. Carrier is one interface, and Carrier uses Wormhole, and then it comes in through Wormhole. It goes to Moonbeam, and then it gets routed to the destination parachain. OK, and that's it. Thank you so much for your attention. And if you'd like to check out the slides, you can access them at bit.ly/moonbeamdenver. We also have a booth. We're in Devtopia, and I believe it's booth number 201. We are right next to Wormhole, so come by and see both of us. Thank you.
Okay, thank you for that. Up next, we have Mate Bai from Turn. So give him a huge welcome.
Hey, hello everyone. That's correct. Thank you so much for having me. So yeah, that's correct. My name is Maciej. I am CTO and the founder of Turn. From today's talk, you can expect everything about interconnecting chains together. So in Turn, we provide the layer that shuffles the assets between, that shuffles the calls between the chains. And then the next step that is going to happen is building out the hub of smart contracts to use. So Turn itself, we do have a parachain on Polkadot. We also do have a parachain on Kusama. This is running under, this is providing with the smooth Polkadot consensus. But what we also do have is the whole settlement layer, the set of smart contracts, and the set of kind of this application layer that provides full EVM compatible access to provide the way for orders to be dispatched, and the execution layer that fuels the execution engine. So a little overview of the landscape. We all know the ecosystem is thriving now. EVM seems to be very much, in our eyes, the standard of how the user base is really interacting, how all of the toolset is interacting with the blockchain itself. Once you deploy a rollup, once you interact with L2, L3, it is pretty much expected that everything follows EVM standards. All of the toolsets is there. All of the tooling, metrics, analysis, everything is there available for EVM. So we're very much aware of that, and this is how we also crafted our architecture to be very much compatible for this. But we also do not forget that there is many thriving ecosystem on layer 1. So Polkadot, Solana, Celestia, Cosmos, Sui, like they're all expanding their users bases. They all provide different standards sometimes as well. So this is the problem that we also address in turn. Not only we are providing the solution that is capable to connect to any EVM, but we also abstract the layer between L1s to provide this coherent kind of execution layer, easy to access for users and for any smart contracts that hooks on top. So the easy division of Tern. Tern has started with this grandiose vision to provide the interoperable smart contracts. As simple as it sounds, it does need the execution layer to provide essentially for all of the smart contracts that are running, for all of the transfers that are happening, for all of the generic calls. They will not be effective if there will not be a layer of execution behind that would essentially receive those orders, receive the balance transfers, receive the generic calls, and dispatch them to the target chains. And this is very much on our eyes to provide with the execution layer for the coming months. And we do it by providing the protocol that allows for the trustless interactions between users who dispatch the orders. And the user could be either a user that just clicks through the user interface, or it could be an application that submits the orders directly to any of the connected chain. And it could also be the smart contract itself that also acts as one additional client and dispatches all of the calls. The calls are then being processed by executors. And then we also have the verification layer provided by attesters that are then checked with the on-chain validation system that is hooked into the parachain itself. So this collects into a modular stack. The settlement layer, this is something that users, executors interact directly with. This is a set of EVM smart contracts that is deployed into major L2s and into really anything that is able to dissect Solidity smart contracts. Then the following layer, consensus and validation. This is provided by the parachain. So we store as much data as we can, essentially to cost optimize the settlement execution layer. We provide all of the data that is necessary for validating all of the traffic that goes on the parachain itself. So the caveat here is also on the parachain itself. We do provide the on-chain trustless validation of all of the headers and the validation of the L2 traffic that is happening. So we do have in works Ethereum Lite client that is also extended with three L2s, Arbitrum-based Optimism. And we also have in works, and this is something that we're going to be rolling out like later, but we do have in works the Celestia Lite client as well. Then there is like a nice little caveat. We do experiment with, and we do have already something that is in works, like an L3 that provides a smooth way for attestations to be collected. And we do it just so that the cost and timing of the overall execution, it is much faster overall. And yeah, the most important part here that we wanted to focus on is the off-chain part. So collection of the roles that work alongside of Term protocol to provide with the smooth execution. So executor, this is the pivotal role for us to provide the on-chain liquidity. This runs as an off-chain component. Executor follows Term protocol, which could be very much simplified into like a simple open market game. So user specifies the parameter of the order, user specifies what needs to happen, and also user specifies the reward that is able to essentially give away to executor who's going to be picking up the order. So executor is constantly evaluating the orders. Shall the order match essentially the criteria that executor has set out? Is the spread matching? Is the order going to be cost effective? It all works on the open market rules. And yeah, if the order is estimated to be satisfiable, then executor is being put into the, is binded by the protocol after they win bidding to execute the order. So execute the order, it simply means do what is expected for you to do by a user, make a transfer on destination chain, and by doing so, you'd be able to score the reward that user has left for you on the source chain. So yeah, this is more or less really these two steps that need to happen. So on the left side, we have a user that submits the order. And then on the right side, we have the execution layer, executors who are constantly listening to the orders, evaluating. Shall they find the deal well? They're going to dispatch the execution to the target chain. So yeah, we did arrive actually to like a smooth model where the set of the smart contracts, the settlement layer, we have deployed to Ethereum, to Optimism, to Arbitrum, Base. We also have a nice partnership going on via Consensus Scale program with Linea, Binance, and yeah, so this is the kind of the Ethereum L2s. But then also, and this is point one here on this slide, throughout making the parachain itself EVM compatible, we did arrive to the model where essentially all of the assets are seamlessly mapped as an ERC20 itself. So what it means is if you're able to transfer any Polkadot asset, is either using XCM, or we also have our own kind of Terra native kind of like escrow log system to offer the funds as a reward. So it all follows the Terra protocol, but you can offer the funds as a subject to be reward that you're gonna leave for executor on your source chain that doesn't necessarily need to arrive with liquidity directly to be set under the execution. So this is like for us like a nice smooth way to essentially bring on as much liquidity as we can onto the Terra parachain, and then any asset that is living on Terra parachain, this is immediately available as ERC20. Therefore, we essentially arrive to the flow where the settlement layer, all of the executions that they listen, they follow exactly the same procedure, and the software of running executor is not that complicated because it essentially is everything EVM compatible, everything works in either ERC20 or native tokens. So yeah, essentially any asset that is visible in Polkadot Asset Hub could be kind of seamlessly mapped into a ERC20 equivalent once it lands on the Terra parachain. Plus, any ERC20 essentially would do to be used as either rewards or the destination asset that users would like to see being subject of the order itself. In practice, once we invite the executor to be part of the network, we're going to be focusing on ETH, wrapped ETH, USDC, Kusama stables, DOT, and Celestia that follows. The slide about the costs. So we did craft all of these layers of execution essentially to make it quite cheap. The cost of execution itself, this scales down significantly to comparing to like a traditional swap that you would see on a DEX. So like a traditional Uniswap asset swap, this would consume more or less 190K of gas. What executor needs to pay is, this is being scaled down to a cost of a single, the worst case scenario here is ERC20 transfer. When the asset exchange involves the native asset, so Ethereum, then this is much lower, 21K gas. But yeah, still very much, much cheaper than regular swaps on the DEXs. And yeah, for user, this is gonna cost about 70K gas, so also quite cheap. And yeah, this is very much the call to action here for today's talk. So we are collecting and actively looking for partners for us to bootstrap the execution layer. If you would scan this QR code, this would take you to a page where you can start registering as an executor. The stage where we are at right now, all of the setup of settlements is being deployed and is now being under audit. We're waiting still for 2 auditors to verify the contracts. One of the audits has been successfully finished. But yeah, coming weeks, you can hear definitely much more about the next steps of airdrop initiative that essentially we are planning to roll out as part of the Network Bootstrap program. And to make the onboarding as smooth as possible for executors, we also have prepared very nice graphic user interface applications. So if you don't want to touch the binaries to run executor, you can also specify all of the parameters of running an executor throughout the nice graphic user interface app. This could be downloaded directly to Mac, Linux, even Windows we have. So this is going to be an app. You essentially specify, I want to process those selected chains. I want to process those selective assets on those chains, and you can specify the parameters on which, based on, you're going to be evaluating all of the deals. So this follows like a very kind of simplified market making strategy. So yeah, as mentioned, stay tuned to on our socials. We're gonna be rolling out the airdrop program very soon. This is gonna lead essentially the following weeks, the network bootstrap. And yeah, since the token isn't live yet, I would see the airdrop program, the perfect timing for getting involved with the project. We do have very nice incentives baked into the airdrop program itself. So yeah, quite exciting actually time, and the perfect timing for this conference for us to be at. So thank you so much. And maybe there is even some questions that I could help with. Thank you so much. There was no questions.
Oh, do you want to ask?
Question to myself. Right hand is to left hand is
for You're welcome. Okay, coming up next, we have Tensi. So let's welcome Tiago. Yeah, ETHDenver. That one. Yep. It's free.
Make team happy.
Yeah. it's gonna connect it.
Yeah, it's already right.
There you go. And slideshow. Perfect. All set.
Thank you.
All yours.
Oh,
For
let's put
images.
don't allow.
Done a lot?
Oh, yes, yes, allow, because
Yeah.
this is the access. Quit. There we go.
Sorry, guys. Technology is not my strong point, so thank you all for coming today. Thanks for having me. So I'm going to be talking a little bit about Tensi and, yeah, exciting stuff that we are building. Yeah, first of all, my name is Thiago. I'm VP of Growth of Tensi. Yeah, I just joined Tensi like 10 months ago, right after it was found. By the time we were just raising our first round, it was yeah, it was super tough time to raise, but we managed to raise from Ayrton Capital. It was super cool, and yeah, in that time we have only PowerPoint, right? So and it was 10 months ago, so super tough time, but yeah, we managed to get that, and. Yeah, let's jump in the presentation here. So here's like a landscape about app chains. So, and that's the main motivation for Tensi, right? So a few years ago, we only have Polkadot, Cosmos, and yeah, just a few chains, app-specific chains. But right now, we have all this horde of, you know, different approaches, different smells and flavors. But yeah, the app chain landscape has just grown a lot in the last years. And yeah, so one can ask like why to build an app chain, right? So why to build your app-specific chain instead of just deploying your smart contract-based application on top of a layer one, right? Why would I do that? So yeah, there are many advantages for building our own chain. Main advantage is the full customizability that you have. So yeah, in our case here, we are building on top of Polkadot. So we leverage the consensus layer and the execution, the settlement layer of Polkadot. But besides that, you have full customizability, and you are in control of your chain all the time. So that creates a lot of cool stuff that you can derive from that. Yeah, you can have vertical integration, so that allows a lot of flexibility. For instance, you can configure your own token to be the base token for a chain. A cool example for that, which is not in the Polkadot ecosystem, is Osmosis. So yeah, they absolutely allow many tokens to be used as a mean of gas fee payment. So that's one cool thing that you can make in our app chain. You can even have like I don't know, a gasless chain. I mean, you can customize all of that. That's a particularly interesting for enterprise applications. That's a cool use case as well. So yeah, as I said, for any projects that have already a token, a governance token, it brings also more utility to this token, right? Because you can easily configure this token to be the base token of the chain. You can use that for payment for gas fees, staking mechanisms, and all that funny stuff that you can make to build and help to increase in your community, right? So. But yeah, I mean, all of that sounds wonderful, but building app chains, yeah, you just have a lot of challenges with that, right? So I'm going to illustrate a little bit. So first, you have the complex infrastructure management. Yeah, it's just maybe not the most capital efficient way to build. You have a lot of not only operational, but also financial overhead on that. Yeah, I mean, we believe in a multi-chain world, right? So you have to create all this connectivity to bridges, cross-chain communication. That's particularly more easy, I would say, in Polkadot world and Cosmos world, but still, it's a challenge for those who are not familiar to XCM. It's not an easy animal to play with, but yeah, it's possible. And yeah, I mean, it's just another challenge is like the community building, right? Because you are building a whole community yourself. So yeah, to solve all of that, yeah, that's Tensi, right? So for those who are not familiar to this design here, that's a relay chain of Polkadot right here. And Tensi itself, Tensi is an app chain, is a parachain itself. And Tensi has only one purpose, which is to launch other parachains. It's not accurate to say that we are launching app chains on top of Tensi, but it's accurate to say that Tensi is enabling other parachains, leveraging our shared sequencer set. In Polkadot, we have this fancy name for sequencers, which is collator. So yeah, Tensi is pretty much like actually the core business model of Tensi is the shared collator set. That's how Tensi makes money. Tensi is paid by the block production service in Tensi tokens, and that's yeah, that's our model, right? So we are not only producing blocks on behalf of the other chains, but also we produce, we are DA layer, if you will, as well. So the data retrievability is done by us as well. It's done by a special type of node that we call, yeah, data retrievers, on the absence of a better and more inventive name. But yeah, so that's Tensi's architecture in a nutshell. I'd like to, well, I'm VP of Growth, so I'm super happy to show this this chart here. So we are super happy with the first achievements that we did. So we launched in mainnet, in testnet about 6 months ago. During this time, we onboarded 200 new projects in Polkadot. So of course, these projects they range a lot. Like the level of maturity of all these projects, they range a lot. We have individual developers, we have more consolidator projects, but yeah, that's a quite impressive number, and we are super proud about that. Also, talking about community, we have like global communities. We have already ambassadors and people, you know, producing content and you know, spreading Tensi's word in 11 countries. Yeah, it's just super exciting to see this super vibrant ecosystem that we are building. Yeah, about competitive landscape, right? So I think, as I mentioned in the beginning, the app chain landscape has grown a lot in the last years, but we still, like, we believe that we have a lot of competitive advantages, especially when it comes to shared security. So Polkadot is uniquely enabling not only the shared security model, but also all the communication through Axiom. So I think when you combine all of that, that's super powerful, right? So yeah, so here in the left side, you have all these advantages I said, but you still have the disadvantages, which are the crowd loans. Yeah, if you want to bootstrap your own parachain, you are also responsible for you know, bootstrapping your own collator set. And yeah, that's a little bit of the problem that we want to address. So yeah, and we believe that this is going to be reducing really significantly the hurdles to build on Polkadot. When the discussion comes more to this side, that maybe is like more, I'd say, hot or has more narrative. So we have other problems in this infrastructure. So for instance, if you're talking about optimism, so optimism, they don't even have the foolproof thing. So what means in practice is that if there is a challenge, we are relying on optimism team to say what transaction is valid, right? So that's okay. I mean, there's no bad thing on that, but just doesn't work for several applications, right? If we are really willing to build actual protocols, maybe there's not the structure that you want. If you're talking about Polygon, CDK, for instance, that's super centralized infrastructure, so you apply to receive a slot and have the right to develop your own chain in that infrastructure, and so on and so forth. If you're talking about Avalanche, that's the other side. I mean, there's a very high cost to put all the nodes infrastructure in place. So yeah, we believe we are addressing all of that in Tensi. So we are very proud of that, actually, and I think this summarizes everything that I just said. So this is a screenshot of Tensi app. And as you can see here, what we built is pretty much like a wizard. You know, it's pretty much like when you are installing some software in your computer, you just give some parameters and you go through this workflow here. So first you're going to choose if we're going to be, first you connect your wallet over there. It can be a MetaMask wallet. We implemented a connection to MetaMask using snaps, which was super cool. Before, you needed to connect using a Talisman or Nova wallet or any other Substrate wallet. Now it's feasible using MetaMask as well. So once you connect your wallet, you are redirected to this screen here. You select the template you want to do. That's another super cool thing about Polkadot. So Polkadot has these precompiled templates. And the way we structured that is that our EVM template is a fork of Moonbeam template. We have also a Substrate template and a custom template. In the case of Parachain wants to delegate the block production functionalities to Tensi, it can be done also with this type of custom deployment, right? So here you give some parameters, right? So the name of the token, the amount of decimals, the pseudo account, which is the master address, which is the master address of your chain. Other stuff you can input here as well, like your gas fee policy. Maybe if you want to deploy smart contract on top of your chain as well to make some some token distribution right in the Genesis. I mean, you can configure all of that here. And at the end of the process, what we have is, it's a full running chain producing blocks, already with integration to RPC endpoints, to block explorers, and a lot of integrations to other tooling as well, like wallets, indexers, bridges, you name it. So we are constantly looking forward to having more integrations here. You can think of Tensi app as pretty much like a shopping cart, So we just select the items that you want to, eat, and we cook the dinner for you. That's another way to explain how Tensi works. That's another super cool thing that's uniquely enabled by Polkadot, the forkless updates, right? So imagine that once you deploy your chain, you want to, change the indexer that you are using. So that's fine. You can just update your runtime and kind of redeploy your chain by leveraging this forkless update infrastructure. Yeah, that's pretty much like the UI of Tensi. And once you connect your wallet again after deploying the chain, this is going to be pretty much, and I'm sorry that I don't have a print here, but it's going to be pretty much like a control center of your chain. You're going to have like dashboards. You're going to have all the other tooling. You're going to have your RPC endpoint, your links to your block explorers, and all that stuff. So it really becomes like a control center of your chain. And that's pretty much it. I think we are already out of time. But yeah, I really encourage you guys to follow us in the social media. We are super excited about the community and about everything. So follow us in Twitter, follow us in LinkedIn, whatever you guys prefer. Yeah, it's super happy to answer any questions you guys might have. And thank you very much for listening.
Okay, last but not least, let's welcome Luis Ramirez from Gear Foundation.
Thank you so much. Okay. Okay, let's wait a little bit just to have the screen here. Just give me 1 sec. Okay, yeah, thanks so much, everybody. I'm pretty sure that you are a little bit tired. So who's gonna be at the party right now after the talk? Yeah, you're ready, right? Okay, last talk, but it will be something really interesting for you to learn about Vara. Have you heard about Vara Network before? Please help me. Wow, nice. It's something pretty cool to know that Vara is in the house. Well, this is me. Basically, the last 2 years, I've been involved in hackathons. All the hackathons that we can be part, we are there. And LATAM, mainly in Mexico, but we are working in different countries. Right now, I am in charge of the development community. I am head of DevRel for Gear Foundation. So today, I'm going to talk about Vara Network and signless transaction. This is something really nice. But before to talk about what we have for the developers something very interesting. Let's talk about the basics. Git protocol. We all understand the core technology of Polkadot, right? Substrate. Well, Substrate, it's a modular framework to create basically any kind of blockchain using pallets, right? Well, with that technology, we use it. So Git protocol is substrate-based, okay? We use substrate, but the part of the smart contract, we change it. So instead of using Ink, which actually is the programming language that uses Polkadot, we use Rust. Okay, so what are the cool things about the Git protocol? We have here three pillars. The first one is actor model. And this paradigm is really interesting because basically you can see as a basic computational entity as a model. Everything is an actor. An actor can communicate with other actors. And this kind of communication is asynchronous. So this is really important because that makes part of the parallelism. What it brings, basically, fast transactions. It's really interesting. And WASM, we all understand WebAssembly, basically what it makes forkless blockchains, right? But also WebAssembly brings to the ecosystem something really important. Instead of one developer understand from scratch one programming language, if you use one of the programming language that is compatible with WebAssembly, then you can join us. So right now we use Rust for the API, and also we are compatible with AssemblyScript, but we are working to do more programming languages accessible to the developers, and that is because we use WASM on the top of the technology. And the third pillar is persistent memory. And this is a really interesting thing about the memory. Yeah, because when we interact with the smart contracts, every smart contract has its own state. And that is possible because on the bottom, we utilize clever memory virtualization techniques that basically at the end for a developer, it enables to access to the state with one call and forget all the complicated things that you need to do and other stacks, okay? So this is important. Git protocol, you can see it as a black box, okay? This black box, it could be implemented in different kind of networks. So the first network that implements Git protocol on the top is Vara Network. So Vara Network basically is a layer 1. It's a scalable and secure layer 1 built on top of Git protocol. What brings Vara Network to the ecosystem? Well, basically, as I said, you can use, for example, Rust and TypeScript and avoid domain-specific language. So you don't need to learn a new language if you want to enter into the ecosystem. And we are working to bring this kind of features also with Go and C++. For all the people who wants to learn more about the technical stuff, we have the Academy. This is basically an online course that you can do on your free time, and you will understand how to use Rust to implement smart contracts in an easy way. So try it, and you will be really happy to see how easy it is to build smart programs in Vara Network. Also, we have our ambassadors program for all the people who likes the blockchain technology. It doesn't matter if you are a technical guy, girl, or if you like another kind of stuff on the blockchain ecosystem, you could be part of this revolution. And this is one of the more important things that we have right now is basically the grants. Everybody wants to know what technology is giving grants to build and grow the ecosystem. Well, Vara Network is right now giving grants for all those developers and projects who want to get in and build something really nice and incredible. We help you to come with us. This is more information about the developer program. Basically, if you are trying to build gaming, if you are trying to change from Web 2 to Web 3, and you have a great idea, or if you want to get technical support or get more tooling, it doesn't matter what you want. We have all the information and tools for you. Okay, let's talk about the more important thing, because yeah, when we understand something new, we want to realize what is the difference between what there is outside the ecosystem and what is new on this new ecosystem and this new platform. Vara Network is young but powerful. We started mainnet in September of the last year, so we are growing with different integrations and apps, but we have these kind of features that are really powerful. Let's talk first about delay messages. Delay messages, basically, you can think as the way how you can create one smart contract and avoid off-chain interactions. How is that? If you build, for example, a streaming platform, you normally wait till the end of the month for the platform to charge the user and validate whether the user is active or not, right? So normally this kind of behavior is triggered by an external event from an off-chain application. But here with delay messages, basically one smart contract can send one delayed message to another contract or to itself. So basically one smart contract can say, okay, I will send a delay message, and after 30 days, you can come to myself and ask a lot of stuff and validate. Okay, so this is basically something cool about the delay messages, full on-chain apps, and specify the time in the future. Another cool thing we have is the payless transactions. And this is really awesome because when we interact with a Web3 application, the first thing that it asks to the user is to get tokens, right? But sometimes this is really complicated because the user needs to know where to get it, and where are you listed, and what kind of platforms can I get your tokens and all that stuff. So the user don't want to use this kind of application, right? Okay, the vouchers basically are the core inside of the payless transactions. Vouchers is basically a part in a smart contract where you can send tokens before to use the application, and that enables to the final user interact with your dApp without paying tokens. That's incredible, and that brings a lot of use cases to the ecosystem, because with this functionality, we can help to bring more developers to build and more users to interact with the Web3 ecosystem. And also we have the signless transactions. How many times have you played or you use an application, and every time you interact with this application, the dApp asks you to sign the transaction? Every time, right? So if you are using a game or a DeFi platform, and if you want to interact with this application but just avoid this kind of messages, then the signless transaction is basically what we need. We enable trusted sessions, which basically we create one session for one user in one dApp, and we just set the amount of time for the application to interact, and we create in the middle a key pair, basically a private and public keys that acts on users' behalf. Basically, this account interacts with the smart contract, and every time that this transaction is to be signed, we use this temporary account. Let's see how it works. Let's check how is the internet. First, for example, we have here one dApp for the ecosystem. This is a Mexican application. One team in Mexico built this beautiful application, and they use vouchers. Okay, so can you see? I'm gonna sign in with Zero Balance Wallet. I don't have tokens here. I'm gonna click on play. Okay. Yes. Okay. It's fast, the internet. It's good. Let's give and sign in. Okay, it says that I need to reload my web browsers. Let's click on register. Okay, here it says creating the voucher. As you can see, the user don't need to do anything. So this interaction is built on top of the app on the front-end side. And now we need to sign just to have this voucher that will enable the user interact with the app without paying any tokens, okay? So right now we have the voucher. We don't have tokens yet. We only have create the voucher inside the smart contract, and the smart contract understand that when this user interact with the application, basically all the interactions will be for free. Why? Because we send tokens to the voucher, and every time that the user wants to interact with the application, the voucher uses these tokens to pay the gas. Okay, so let's go and mint one NFT. And here we have different kind of NFTs, and we click on mint. And this moment, we are giving three NFTs to the user. So as you can see, it's adding tokens to the voucher, and I paid, and after I signed the transaction, and now I have the NFT, okay? And we still have zero tokens. This is basically the incredible thing talking about the vouchers. Let's see how does it work now, the signless transactions. Okay, we have another application here, the Battleship game. I'm pretty sure that we all know this application, or we have played this in real life. Okay, let's use this wallet. This wallet has tokens, as you can see, 182 tokens. And, okay, let's create our map of the ships. And let's start to play. Okay, so this is the normal way the user interacts with the application. So you click on the space where you want to put the bomb, and okay, I got it, and I click, and this is the normal way we interact with the games. But let's activate the signless transaction. So basically, as I told you before, we create temporary key pairs. So this is the public key, and we have the private key also generated, and we set it just to sign the transaction. And right now we have 0 varas, and we can create a signless session. Okay. So we just need to wait a little bit. Okay, and we just set a password, because in the moment that we want to disable this, with the password we can do it. So we just click on the space, and I don't sign. Okay? So this is the way we interact with signless transactions, because we basically enable to the user to interact with an application, but enable the user to use it for certain amount of time. Okay, so I still click on the different spaces, and as you can see here, we have the time that the user is using with the signless transaction. So basically, that's all on my side. So if you want to keep in touch with me, this is my information. Thank you so much for your time.
Thank you everyone for coming. So let's enjoy some pizzas and some drinks down here, and we hope to see you tomorrow at the Polkadot booth.